Hi friends, I guess we are live. Let me just check if everything is working as expected. Please confirm that and then get back and then we'll start the session itself. Let's just wait and check for audio. Yeah, I can see myself, so I guess things are all right, no issues whatsoever, because I can see the live session myself, right? So yeah, I can also hear it. Sounds good. So I'll take a few questions before we start the session. I answer one of the questions. So somebody's asking, how long is the placement paused? There is no pause per se on placements. There are some of our students who are interviewing, but some companies have paused it. From our side, there is no pause. We have been continuously in touch with companies. There are some companies that are conducting interviews over Skype, especially those interview loops that they've already started before the shutdown. But I hope as soon as the shutdown is over and as soon as employees are back at their company offices, I'm hopeful that the companies start their recruiting process, wherein new candidates will start their sessions, right? So people who have already started with their interview loops are carrying on. But this pause is mostly from some of the companies. Again, it makes completely logical sense, right, from their perspective, that they're not able to conduct because everybody is working from home. Some companies want the placements to be from their office itself. Those companies are just waiting for the shutdown to get over. Okay. How can we do deep learning deployment end to end? Yes, we'll do it. So if you notice, the way we are doing these live sessions is we are covering topic by topic, right? So let me just go to Applied AI course. So the way I'm planning to do these live sessions, again, we discussed about it. First, I'm doing basically fundamentals of programming, right? Right now, what we're doing here is fundamentals of programming. We are just using, yesterday we did some recursion, basic functions, right? We did some basic NumPy, right? We are still in this chapter, right? We are not yet finished pandas, by the way. We have done some computational complexity. Today, we'll do some more mathematical programming. Today, I thought I'll cover a couple of questions. Again, the last two questions are actually questions that have been asked in interviews, like for machine learning engineer interviews at Yahoo Labs and at IBM Research, right? So I'll cover a couple of those actual real questions that have been asked to machine learning engineers and data scientists at these two companies. So I'll cover a couple of real questions asked in real interviews also. So having said that, see, we're still here, right? Tomorrow I'm planning to do a live session. Again, that will also be open to everyone. Tomorrow's live session, as I mentioned it at the bottom of this current sheet, is we'll do strings and regular expressions. So we'll solve a bunch of problems, common mistakes, errors, just on strings and regular expressions, which is a very important topic for machine learning in general. So I'll cover that, right? So tomorrow we'll do that. We'll also do 1 or 2 sessions on pandas. Once this is over, we'll go step by step. Once we finish this, we'll take some problems from EDA, right? I'm also thinking of covering Seaborn in much more detail by taking a real world example, going through the data analysis step by step. Again, even in our exploratory data analysis chapter, we have gone through a real example and gone line by line code and all of that. I thought I'll pick one more. Then we'll go to linear algebra, right? So in linear algebra, again, we'll revisit some of the concepts from NumPy and SciPy. But we'll do it with respect to the concepts that we learn in linear algebra. For example, we'll see how to write a program to determine if, given a hyperplane, given an n-dimensional hyperplane, whether a point is on one side or other side, how to compute the distance between them. We've discussed the mathematics here. We have discussed some of this code also, but I thought I'll take a real world problem and solve. Again, we'll do one session on linear algebra. We'll do probably 2 or 3 sessions on just probability and statistics code, right? So I'm planning to go step by step, chapter by chapter, module by module. We'll surely come to deep learning. Forget about deep learning case studies. We will go through deep learning. Again, if you go through our deep learning case studies, as somebody was asking, right? If you go through some of our deep learning case studies, they're actually covered end to end. Of course, we will cover some topics on deployment. We have done a live session earlier on deployment of machine learning and deep learning models using, this is using Flask and EC2 and AWS and things like that. So please go through some of those live sessions that we have already done in the past. We'll do more live sessions for sure, right? So that's the important part here, right? So I'm planning to go step by step, topic by topic. As long as this lockdown is there, we'll go topic by topic and do more and more problem solving. Again, the objective here is mostly code walkthroughs and to solve coding problems for each of the concepts that we have in our course. For each chapter, we'll spend 1 or 2 days, right? I understand that I'm spending more time in Python programming because if you're comfortable and good here, rest everything should follow. That's why I'm spending almost 5 or 6 days just on fundamentals of programming. Okay, sounds good? So yeah, so what are the questions? Somebody saying, what are the, okay, so again, we will do a session on Matplotlib, not on Plotly. We will do a session on Matplotlib because that's what we discussed extensively in our course videos. But we'll do it, instead of doing it theoretically here, we'll do it in the EDA chapter. Again, if you look at our EDA chapter, we have already used a lot of functionality from Matplotlib, but we'll cover more examples. We'll cover more functionality now. If lockdown is lifted, then also these sessions will go on. Again, we don't have any plan because we have some students who are college going students. We have some students who are working professionals. We don't know. Again, we have the weekly, see, right now we have the weekly live sessions. And the reason we conduct them weekly is because people only get time during the weekends to attend these live sessions, right? So during the lockdown, since everybody is at home, we are conducting them daily so that they also keep their mind occupied on improving their skills and not on other stuff, right? So somebody says you're getting poor video quality. I don't see that. I'm getting like 720p. That's the best Google will allow right now, right? So, okay, sounds good. Anyway, I think we should get started. I have more problems today. I have like 5 problems that I wanted to go through. So without any delay, let's jump into the discussion. I believe some of you, okay, again, I cannot look at these comments as I'm explaining this because they're completely on 2 different tabs. But I believe yesterday I was reading through some of the comments after the session. Some students were asking us about what is recursion. Guys, I'm going to assume that you know the basics of Python, because there is no point in covering basics of Python because we've already covered it as part of our course and there are tons of resources available. My prerequisite, if you recall, for every live session, I'm clearly making it clear that the prerequisite is that you know basics of Python, right? So please understand that I'll not be able to cover the Python basics or any of the concepts basics. The objective of these live sessions is to improve your programming skills, is to solve more problems in the context of machine learning and AI. It is not to cover the basics. I hope that objective is clear, right? So let's continue with this. Okay, so where were we yesterday? We understood, I explained to you about this. This is a very nice diagram from Emory University Math and Computer Science Department. I've explained you how this works, right? And then we ran out of time. So now somebody gave a very good suggestion today over email that can you explain the mathematics and how to convert the mathematics to equations? I felt that was a very good suggestion. So I'll try to follow that. So how are we doing this? So what is this? We want to compute the integral of f of x dx from a to b. This is what we want to compute, right? How are we computing this? We said this is roughly equal to, this is approximately equal to summation, right? You're going to sum multiple things. What are we going to compute? From x equals to a to b in the intervals of delta x, right? So first you will take x equals to a, then x equals to a plus delta, then a plus 2 delta, a plus 2 delta, so on and so forth up to b. That's what, see, you're approximating the integral with a summation, right? What are you going to compute? F of x will give you this height, right? Then the width, this is nothing but delta, right? Into delta, right? So you're going to compute, so x is your value, which will take a, then a plus delta, then a plus 2 delta, so on and so forth, up to b. I've written the b here, right? So you take you compute these products and you sum them up, right? So this is the approximation we discussed. Now the question here is, how do you convert this into code? It's very simple. Look at this. What are you doing? How can you write this? You can write this as f of x multiplied by delta plus f of x plus delta multiplied by delta plus f of x plus 2 delta multiplied by delta, so on and so forth. You're repeatedly doing some operation and you're summing up. Look at this. Whatever result you get, you store it in a temporary variable. You sum this with this. That you sum it with this. So what you're computing literally is you're repeatedly computing this while changing the parameter that you pass to this function, and you're summing it up. So what tool that you have in programming that helps you do something repeatedly over and over? Loops, right? So this should tell you that you have to create a loop. This should tell you the summation, because you're repeatedly doing it. This should tell you that you have to create a loop, and you have to create a sum variable which you keep updating with this value, because it's a summation, right? So very simple constructs. Again, when you get the logic, you have to connect the logic to programming concepts, especially if you're a beginner programmer, right? Once you have this, you just have to translate it into code, right? So again, yesterday we discussed, I hope this math part is clear. I discussed this yesterday also. And as we discussed yesterday, if the delta, look at this, what is this? This is your delta, right? So this is your delta. The smaller the delta, the more accurate your area under the curve would be. So let's start writing a function. Okay. So first let's implement f of x. Again, remember, what is our problem? Our problem is find the area under the curve sin x by x in the interval minus 10 to 10, right? So let's actually plot this first. So plot sin x by x, right? So plot, Google will plot it for us, thankfully. Okay, so from minus 10 to plus 10, you want to plot the area. That's what you want to compute, right? Cool. This is looking good. Okay, so let's go into it. Okay. So first and foremost, okay, we are doing this. Okay, we are getting this area and we are computing this. Cool. So how do I compute f of x? Define f of x. I'm just creating a function and I'm saying return sin x by x. Very good. And this is my lower bound. This is my a. This is my b. This is the lower bound of my integral. This is the upper bound of my integral. Right? Very simple. First, I'm just creating a function. Do you see a problem in this function? See, can you find a bug in this? There is a bug actually in this code. It's literally 4 lines of code, but there is a bug. Can somebody tell me what the bug in the code is? Okay, I'm looking for your... somebody says video quality is poor. I don't see that. One second, let me check my streamer. My streamer is streaming at 6 Mbps. Right, so that's the default speed that I typically, that's more than what Google asks me to stream at. So this is at proper speed. Let me refresh my YouTube. I mean, again, I can see it perfectly all right. I don't see any major problem. Yes, good. Couple of folks have said, okay, we have not handled the case which is x equals to 0. Again, the reason I picked this is because there is a problem. If x equals to 0, in programming, you have to always handle boundary cases. It is very, very important for you to handle boundary cases. Right? It's extremely important. Okay. There are some more errors in the code. I'll go step by step. Actually, before we go even there, right? So let me tell you one more thing. There is one more problem actually in this. Actually, if you think about it. There is one more logical bug here. Can anybody find what that logical bug is? So in this way, if I'm computing the area under the curve like this, there is a bug in here. Can anybody tell me what is the bug? What is the problem in this? Okay, so let's call it this way. Okay, let's just say integral. Okay, fine. Let's not worry about it. It's okay. Let's continue. We'll come to it when the situation comes. Okay, so this bug, you're clear. I'm happy that you got it. So all I'll do is if x is not equals to 0, look at this. I'm importing math. I'm just importing math. I'm saying if x is not equals to 0, return sin x by x, otherwise return nan, not a number. Because division by x will create an error. I'm just saying not a number, right? Very simple. Okay, my lower bound, upper bound, whenever I define a function, I want to test what happens. So I'm printing f of 0. So if I execute this, what happens? Look at this. If I execute this, what happens? Print f of 0. It is printing nan. Very good. No problem. But when I say print f of 1, I'm getting an error. What is the error here? Look at this. Look at the error. It's actually very simple to read. If you read this error, it says, where is the error? The error is, look at this. When I executed this line of code, this went to this function f of x. In this line, there is a problem. What is the problem? Name sin is not defined. Sin is not an inbuilt function. You have to say math.sin. Right? Let's not forget that. Very common mistakes. Not using math.sin and using math.abs instead of using abs that we saw yesterday, right? So I just modified it and I said math.sin. Cool. Am I getting the right answer? Seems like reasonable, right? So I'm getting NaN, f of 1 is this. How do we test it? We can always test it. I can just go to f of 1. So this is where 1 is. If you look at these values here, if I go to f of 1, look at this. If I go to f of 1, okay, so if I go to f of 1, it's close to 0.8 something. Okay, cool. Seems sensible. Very good. Now let's write the code, right? All you have to do is translate the integral into, look at this. We just have to translate this summation. We just have to translate this summation, which is f of x delta, and from x equals to a, or my lower. In this case, I have lower and upper, right? So that's what it is. So I'm starting with my x equals to minus 10, right? Which means x equals to a plus delta, a plus 2 delta, so on so forth up to b. So look at how I've written my code. Again, it's very simple. Once you get this, once you realize that you have to write a for loop, it's actually straightforward from here. X equals to minus 10, right? So because I want the area from minus 10 to plus 10, my delta is 0.1, my area initially is 0. Because I have to keep adding this value over and over and over again. So while x is less than equal to 10, look at this, while x is less than equal to 10, because as long as x is, because I want the integral from minus 10 to plus 10. Look at this, I want it from minus 10 to plus 10 till the time b is plus 10. That's why I'm writing this in a while loop. I want to print. As I told you, I always print things to make sure that everything is working well. If x equals to 0, look at this, I want to continue. The reason, again, this is a very important boundary case that I'm handling. Because if I don't handle this, if I call with f of x equals to, if I call, see, in this iteration, right, when I go from minus 10 to 10, and if I keep incrementing my f of x, if I keep incrementing my x with delta, at some point I'll get x equals to 0, and f of 0 is NaN, right? NaN multiplied by some delta, if I add this to some, to area, it will become NaN, right? So there's no point adding this. So what I'm doing here is I'm saying, if x equals to 0, just don't compute f of x, don't do any of this, right? Just don't do this. Just don't compute f of x and then add this whole thing to the area. Just skip it, right? So this is a boundary case, an important boundary case that we should always handle, number one. Number two, look at this. I'm saying area equals to area plus equals to, so I'm updating my area. Look at this. My area is nothing but, my area equals to area plus f of x into delta. Exactly the same function that we have here, right? For each value of x, I'm computing f of x, multiply it with delta, add it to this variable called area. After that, I'm changing my x. X also, x is now minus 10, then it will be minus 10 plus delta, minus plus 2 delta, so on and so forth. At the end of this whole while loop, I'm saying print area. I execute it, I get an error. So what happens here is, when I execute this, I go into an infinite loop, right? This program never ends. I had to force it. Because it doesn't end, I have to click this button to force stop this. Can anybody suggest what is the bug in this? Why is this going into an infinite loop? Again, very common mistake. This code is going into an infinite loop and it's not ending. Any suggestions why? Any suggestions why? Why is the limit condition not considered? I'll come there. First, let's answer this question. Somebody says, yes, good. I'm happy you got it. Somebody got it. Very good. This guy, so very good. So Pratik got it. He was careful to see the code, right? If you notice, Python takes care of indentation. So this whole thing is inside the if loop now. Is inside the if, because Python does indentation automatically, right? So if x equals to 0, only then you're updating the area and x. So these two lines should be outside the if. That's the problem. Number one, right? So number one. So the problem here is indentation error. This should come here. This should come here. Lot of people, especially people who are new to Python, mess up indentation. Very common mistake. Now somebody asked me, why are we not handling this case, right? So again, we can handle it gracefully when x equals to 0. Again, there are two ways to handle it. When x equals to 0, as you come closer and closer to 0, the y becomes 1. So you can say, okay, sin x by x. So what we can do here is, if x is equal to 0, we can say return 1 instead of NaN. Right? That's one way of handling it. Because we know that for this function, again for that you have to know the concept of limits in calculus. So limit f of x, which is sin x by x, right, as x tends to 0. What does this mean? Again, it's a very simple mathematical concept. It says, what value does sin x by x take as x comes closer and closer to 0? So let's actually zoom this in. If you notice, let's just zoom this in. Okay, so let's just zoom this in. Look at this. If I'm coming from this side, if I keep going towards 0, look at this. I'm going towards 0, right? As I keep going towards 0, my y is moving towards 1. Similarly, from this side, if I keep going towards 0, my y is going towards 1. So I can say, because the limit x tends to 0, sin x by x equals to 1, I can just say, forget all this. If I have my function f of x, if x equals to 0, I'll return 1 instead of this. That will solve the problem. Yes, that's a very graceful way of solving it. But I wanted to show you the problems with NaN. Right? That's why I took up this case. If you were to implement it in production, the better way to implement this is to say return 1 here. And you say, okay, give a reasoning and say, we are returning 1 because limit blah, blah, blah. This logic. Because limit x tends to 0, sin x by x equals to 1. And that's a right logic. If you were to implement in production, that's how you implement it. But I wanted to show you some boundary cases, right? Especially with NaN, what errors can go wrong with NaN. Okay, so I modified it. I got my area outside this. I indented it properly enough. Now, okay, I execute this code. Okay, is there a bug here somewhere? Oh, so this is buggy. I'm sorry. I need to stop this. Okay, so this is buggy. So this code will execute. Okay, so if I execute this code, what happens? Okay, I got the answer. Okay, I executed this code now. See, all I have done here is I've just changed, look at this, I've just changed this indentation to be proper. Now, what did we compute? There are two things. What we computed now is integration of f of x dx from -10 to 10. This is what we computed. There is a slight difference between this and area under the curve. There is a slight difference. Let me explain that. There is a subtle detail that I skipped earlier, which I wanted to cover. Okay, so let me tell you. So what we computed now is integral f of x dx, right? So this is what we computed, where f of x is sin x by x from -10 to +10. This is what we computed by using a summation x from -10 to 10 with some delta equals to 0.1. This is what we computed, right? F of x into delta. This is the approximation we have taken, and this is what we computed. But I have a question here. Okay, this is actually not the area under this function. If you look at this function, right, how does this function look like? Okay, let me show you the function instead of me drawing it, right? So there is a small problem. It is not, so this, what the integral that I computed is not exactly the area of the function from -10 to +10, this area. It is not equal to this plus this plus this plus this plus this plus this plus this. It's not equal to. This area is not equal to this. Can anybody tell me what is the mistake? I intentionally made that mistake. Can anybody tell? This highlighted area, this area, this area, this, if you measure the actual area, it will not be equal to this. Can somebody tell me what is wrong here? Okay, let's see the comment section. Yes, we need to take absolute value. I'm happy you got it. I'm very, very happy. People are figuring it out. Very good. So the problem here is this, okay? The problem here is, very interestingly, when you take f of x delta x, look at this. If you take f of x delta x, right? The f of x here, delta is always positive. Remember, the delta we took is 0.1. The f of x here is positive. So when you multiply a positive number with delta x, you get a positive number. But what happens here? Here f of x is negative. Here f of x is negative, right? So what do you get? You get a positive number here, you get a negative number here. So what we are finding here, what we are finding to this integral is actually area, look at this, what we are finding here is area above the x-axis, all the area that is above the x-axis minus the area which is below the x-axis. That's what we are finding now. So the fix to this problem is very simple. Take the absolute value. That's how you get area. So what the code that we have written right now is for integral f of x dx. right? That's what we computed. But if you want area under the curve, because of this positive and negative side, you should always use absolute value. This is one of the most common mistakes. Again, I've asked such questions in interviews and I've seen people mess up the absolute value. I give them hints. I tell them they can't figure it out. That tells me that they're not thinking thoroughly. If they cannot think of a very simple function like this, I actually plot this function and explain them how the function looks. But they're not able to figure this out. Again, why are interviewers asking these questions? Because interviewers want you to think, want to understand if you can think critically and take hints, because they have to work with you as a teammate tomorrow, right? They want critical, deep thinkers, right? So I hope this is clear. Okay, so that's where we are. Cool. Now we got this. Now when I executed this whole function, again, our code right now is not for the area. Our code is actually for the integral f of x dx. Okay, from minus 10 to 10, where f of x itself is sin x by x, right? So all that is cool. What is the answer that I got? I got an answer which is, okay, let's see. I got an answer which is 3.3111. How do I know that this answer is correct? That's important, right? If you think about it, how do I know that this I got some answer? Again, whenever you write code, you should test the code. It's extremely important to test the code you have written to ensure that it is correct. So how do you check or how do you test that this code is correct? Any suggestions? I would like to hear from you guys. Oh, so very true, very true. The smaller the delta, somebody suggested very good point. As delta becomes smaller, if delta is 0.0001, as delta becomes smaller, the area that you get is, or the integral that you get, right, is closer to the original value. So let's just, because I've not taken the absolute value here, the integral is, the integral a to b f of x dx is going to be more accurate. No doubts about it. Guys, we'll come to space and time complexity. Just wait for a second, right? Again, there are inbuilt functions to do it also. I know that. But in interviews, people will say, please don't use inbuilt functions. I want you to write the code, because they want to see how you write code. Because as a machine learning engineer also, you have to write code, right? So let's not forget that. There are 100 ways of solving it. I can solve this problem in one line, right? As somebody pointed out, there is actually a function called trapz, right, in NumPy. You can do that. But the question is not that. The question is to test your programming skills. Okay, where are we? Manually calculate the value. How do you calculate the value? Google the answer. Try Googling it and tell me. Do unit testing. How do you do unit testing? Again, this is the problem, right? So you can tell me do unit testing. How do you do unit testing? What are your test cases? How do you do black box testing? How do you do white box testing? How do you do that? Validate through library output. Okay, that's one possibility. Cool. But imagine in an interview, the interviewer says you can't use any libraries. Now, how do you validate that your code is correct? Okay, this is one good option. Manual calculation. How do you calculate manually, guys? Somebody please teach me. Can somebody do this right now? So sin x by x. Can somebody compute this for me? Sin x by x dx. Please tell me what is the answer. It's an open challenge. If somebody can solve this for me and put an answer here in the next few minutes, I mean, you're brilliant with calculus. I'll agree that. It's not such a trivial problem. Somebody says Google the answer. Try Googling it and let me know if you got an answer. How do we test it? Okay, I'm looking for ideas, guys. I'm looking for ideas, please. No, very different. What does it mean? No, very diff. What does it mean? I didn't understand this. Can't calculate. Okay. Yeah, it's not easy. Trust me. I mean, I can calculate an integral of a variation of this. I can't calculate this integral. Trust me. It's very, very tough. There is actually an integral like this. There is an integral like this. 0 to infinity sin x by x dx. This integral itself is a very hard problem. And again, since we know there's this function, look at this. Or you can calculate from minus infinity to plus infinity also. You can calculate this integral, right? But this, try integration by parts, please. I mean, be my guest, right? So just try to find, how do you do this integration? It's not easy, by the way. It's there's something called a Feynman's method of integration. Again, as I told you yesterday, Feynman is one of the greatest physicists and teachers of the 20th century. So there is a technique called Feynman's integration. You can find that out again. It's not easy. Or somebody said pi by 2. Pi by 2 is the integral of what? Again, I think you Googled it, but what is pi by 2? So if you type integral sin x by x, okay, yeah, this is a very nice video, actually very nice video. So if you take, what is the integral of sin x by x, right? So if you take the integral blah, 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 there is a calculation, you get this whole answer, right? Of course, it's a fairly complex integral. It's not an easy integral, let me tell you. And it creates an infinite series here. Again, there are multiple ways. You say, you expand your sin x into a mathematical expression, all of that part. There are multiple ways of doing it, but it's not trivial. That's what I'm trying to tell you. Okay, so look at this. What is the value of integral 0 to infinity? So again, you can use Laplace transforms. There is a ton of mathematics, right? So from 0 to infinity, it is pi by 2. Look at this. Again, somebody posted the whole proof. It is not trivial, trust me. If you have not done calculus for a few years, most likely you'll forget it, right? Again, I'm not brilliant at integrations. I've done a few of them, but I'm not the best. It took me quite a while to figure this out, right? So integral 0 to infinity is this, which means minus infinity to infinity. Look at this curve. So if you just plot this curve, right? Sin x by x. Where is this? Okay. So if you look at this curve, let me just plot it carefully. If you plot this curve, you will see that whatever is the integral from 0 to infinity, this whole function is symmetric. So whatever is the integral from 0 to infinity, the same will be the integral from 0 to minus infinity, because this is symmetric over y-axis. So this integral from 0 to infinity for sin x by x equals to pi by 2, which means integral from minus infinity to infinity sin x by x is pi. Now what are we integrating? We are only integrating from minus 10 to plus 10. One good thing that you can think of is, look at this. One good thing you can do. The way you can test this code is, instead of having minus 10 to plus 10, just say minus 1000 to plus 1000. Because we know that this function, look at this, this whole function will keep becoming smaller and smaller as we keep going forward. Look at this. This whole thing, these values have become extremely small as x increases, or as x goes towards plus infinity or x goes towards minus infinity. This curve becomes very small. So if you take values from minus 1000 to plus 1000, right? That again, you just have to change your code slightly. Just change your code slightly. How do we check, right? So one suggestion, one very nice suggestion here is, integrate from this, you get pi by 2. I've provided the YouTube video. So I know very easily that yes, I just have to use this fact and solve it, right? I'll just say a equals to minus 1000, b equals to plus 1000, and I'll recompute this. If the value is closer to pi, I know that my code is working well. That's one way, without doubt. Is there another way? Actually, there is another way. I already showed you that. Another simpler way is just change your f of x to something that you know. Look at this. I'll just change my f of x to constant. What is my function now? Look at it. Look at my code, right? This is from minus 10. This is from minus 10 to plus 10. Right? What we have written is a very general, it will work for any f of x, right? So all I'll do now is very simple. All I'll do is, I'll change my f of x. My f of x is constant, which means this is my f of x. My f of x equals to 1, right? If this is my x and if this is my f of x, if this is my y or f of x, it is constant. So again, nothing has changed. The whole code is the same. I've not changed the code. I've just changed f of x, right? Because it's easy to verify this. What is the area under this curve from here to here? This is basically a rectangle, length 20, height 1. So area is 20. So much more easy way, if you're not, again, this is certainly one way, but a much more easier way is to just say, ignore all that. I'll just change my f of x, because I know that my f of x computation is correct, because it's just sin x by x, right? Let me change this to a simpler function and validate if everything is working all right. So when I do this, let's go to the answer. I get a value of 20 point. So I just changed my f, right? And I should actually have gotten 20. But what I'm getting here is 20.1. Of course, that could be because my delta is 0.1. As I decrease my delta, this will become closer to 20. Obviously, that's one idea. Cool. But can we do better than this? Right? So what we have done right now is basically what is called as a rectangular method. Why is it called the rectangular method? Because we are using areas of rectangles. Look at this. We are using rectangles to represent, or we are using areas of rectangles to approximate this curve. That's what we are doing, right? Is there a better method? So as somebody rightly pointed out, there is actually a better method, which is our assignment. So that's called the trapezoidal method, right? I'll leave that for you you can take it as an assignment. It's a good assignment to compute. So the trapezoid rule goes as follows. Again, I've given multiple links. There's a very beautiful video from Khan Academy for 12th class students, right? This is something that 12th class students learn across the world. Again, I've taken some nice diagrams from Math 24. There is also a beautiful explanation from brilliant.org, right? So first I try to draw this diagram, right? So I've taken this very nicely explained diagram. I'm trying to plot it. Very good. I get a very big diagram. Like, I don't want this like unwieldy diagram. So I want to shrink the size, right? I don't like this display. Again, showing your data cleanly and beautifully in IPython notebook is also an important skill, because others should be able to read it. So first thing that I think of is, okay, this image is there, URL, I'm giving the URL, but is there any other parameters that I can modify? So I go to image in IPython, right? So where is this, which image I'm using? I'm imaging from IPython.display. Image in IPython.display. I want to know the function definition or the function reference basically. Okay, so let's go to the function. Okay, so here it is. So there is image. Where is image here? Okay, there is image. So here it is, right? So here is the description. So data, URL. Look at, I'm using a URL, right? Look at this. I want to understand. See, when I just tried to show this image, I'm getting a like too big an image. I want to resize the image. Now I don't know how to resize, right? I don't remember every damn function under the sun. It's impossible for anyone to remember it unless they're using this on day-to-day basis, right? So I just say IPython.display image. I want to understand how this works, right? So there is a URL. I'm giving a URL variable here. Now what else can I give? So I go and start reading the documentation here, right? So there is data, there is URL, there is file name. I can also show a local file. There is format, cool. There is some embedding. There is width and height. Now what does width and height here represent? Width represents width to which to constrain the image, height to which you want to constrain the image. Cool, this is very good, right? So I want to constrain this image, or I want to limit the image to a smaller size. So I know that I can use, so I just went to this reference, I Google search for it, and I said width equals to 400, height equals to 400. Again, I'm repeating this over and over again because it's important to learn the skill of reading function references and understanding it. Now when I say 400 and 400, I got this image, right? So I can actually go ahead and say 500, 500 because 400, 400 is too small, right? So 500, 500, okay. Let's just execute it, okay. This image looks much better. So what is the concept behind trapezoidal rule? Trapezoidal rule is very simple. Trapezoidal rule says, if this is my f of a, and if this is my, look at this, this is my f of a, right? This height, this is my f of a. This is my f of a plus delta, right? So now what were we doing? We were taking this rectangle. Earlier we were taking only this rectangle area. So what trapezoid, again, this is a rectangle, right? What is a trapezoid? If this line is not straight, what you get is a trapezoid. So the trapezoid rule, what it says here is, you know what is f of a, you know what is f of a plus delta. So instead of taking this rectangle, also use this triangle. The sum total is a much better approximation than just this rectangle. So a trapezoid is a better approximation than a rectangle. That's the core idea behind trapezoidal rule, or trapezoidal. It's also called as trapezoidal sums. Now, how do you compute the area of this? Look at this, right? Let me redraw this, right, for you. So you have this part. Okay, I'm just drawing larger. Okay, so this area is simple. This height is f of a, right? This width is delta. That is cool, which means this width is also delta, right? This width is delta. What is this height now? This height is nothing but f of a plus delta minus f of a, because this point y-axis is f of a. This point y-axis is f of a plus delta. So that's what this height is. So we know the area of the triangle, right? It's nothing but half of base into height, right? So we know this area, which is f of a into delta plus half of base, which is delta into f of a plus delta minus f of a, because the height is this. That's it. So you got the area of the first trapezoid, right? This is the area of the first trapezoid. Same program like earlier, except that instead of just having the rectangular term, you also have the triangular term to create the whole trapezoid, right? So same, it's the same loop that you have to execute like the previous time. Instead of just having one term, you have two terms now. Now what I want you to do is try to implement the trapezoidal rule. It's also called the trapezoidal sums, right? I hope the intuition is clear. The exercise now is try to find the area under this curve, same curve, or forget about area under the curve. Let's just do f of x dx, right? From minus 10 to 10. Again, the difference between area and this is just basically absolute value. That's the only difference, right? If you want area, just put absolute value function here. That's it. Please do this using trapezoidal rule and see that trapezoidal rule gives better results, more accurate results than rectangular rule or rectangular sums, right? I hope this is clear. Okay, again, to be honest with you, I've asked some of these questions. Again, I've had a wide spectrum of candidates that I interviewed throughout my career. I've interviewed hardcore math guys, I've interviewed hardcore CS guys, I've interviewed mechanical, electrical, electronics, all sorts of folks, right? So this is a very common problem that every engineer, every student of science and mathematics should be able to solve. If they know programming, this is like 11th class, 12th class math, right? I'm not asking any complex stuff. I'm not asking you to solve some complex differential equations or complex mathematics. So for machine learning engineers, very often, again, not always, but very often, they'll give you a mathematical problem. I'll show you a couple of problems by the end of this live session, right? They'll give you a mathematical problem which also requires programming. Because you as a machine learning engineer or a data scientist have to actually write programming to solve mathematical problems. So this is much more appropriate for what you would do on your job, right? So that's one. Okay, so let's go to the next problem. Okay, slightly different problem. Okay, cool. I have this function sin x by x, the same function that we've been using because we are used to it now. So I want you to compute a maxima between minus 2 and 2. Now let me explain what is a maxima. I think people who remember the 12th class maths, again, all these are relevant in the context of machine learning. We will end up using maxima, minima, study it extensively later on in the course, right? I'll show you tons of examples later. Okay, so where were we? Plot sin x by x. Okay, so let's zoom it in. So what I want to do here is this. Let's understand the problem first. Sin x by x in minus 2 to 2, right? So from minus 2 to 2, which means from this value, from minus 2 to 2, I want to find a maxima. Maxima basically means something which is the peak, right? So I'm given this function. I'm not given values of the function. I'm just given this. So I'm given this. So this function in this region, I want to find this peak. Again, finding maxima. This is what is called as maxima. There is also a concept called as minima. So if I'm given this interval, let's assume I'm given this interval and I'm asked to find the minima here. Minima is this minimum value. At this value, you find the minima, right? So that's the concept here. So for our problem, I hope minima and maxima are also called as optima, right? Again, we have discussed this in our optimization part of the course, but I'm just using this because since we anyway learned basics of integration, I thought I'll continue some differentiation also, right? So my problem is clear. Between minus 2 and 2, I want to find this point, which is 0. I know that. Visually, I can see that and find it out, right? But given any function, imagine you are given some function f of x and you're given an interval a comma b and you are asked to find the maxima in that interval. How do you find that? Again, here it's very simple. You just see it. You just see that this at 0, f of x is 1. That's the maxima. But I wanted to write a program for a general f of x. How do you tackle this problem? I hope this is clear, right? Again, just think logically. That's all I'm asking. You don't have to be expert in calculus. Double differentiation equals to 0. Okay. So you have sin x by x, right? Please differentiate it for me. That's certainly one way. You just say, okay, I have sin x by x. I do d by dx of this, right? It will give me some function. right? I'll equate that to 0. This will be some differentiation. Again, you can use, if you're good at calculus, you can use the chain rule of calculus, right? And you can compute this whole thing. Chain rule or product rule, all of that. There are tons of rules, basic rules, right? Then you get an equation here. We have learned how to solve this, right? Given any function f of x equals to 0, we saw how to solve this yesterday, right? In the root finding exercise. We saw that, if you recall. We saw how to find f of x equals to 0, right? Didn't we? Yesterday's live session, right? So we took this example, right? I asked this question, where does sin x by x become equal to 0? So the same logic, instead of sin x by x, if I can compute the derivative. Now, how do you compute? Again, there are ways to compute the derivative, no doubt about it. Again, computing derivative is much more easy. So derivative sin x by x. I mean, you don't have to be expert at it. You can just, what is the derivative of sin x by x? Again, I think I put the link in the notes also. You just do it. Okay, you get this as the answer. X cos x minus sin x by x square. Right, that's your answer. So just make this as your g of x and just solve this g of x equals to 0. You can solve it, right? We learned how to do this. If the derivative equals to 0, then you know it is either maxima or minima. You don't even have to do second derivative. You just see the plot here. Look at this. Between this region, look at this. Between minus 2 and plus 2, you don't have any minima. So whatever point you have where the derivative is 0, right? That point is only the maxima. So you can just say, okay, I find this. Again, some of you may not know what is a derivative. So let me explain that. Okay. Some of you may have forgotten that. Okay. So let me give you the intuition behind what a derivative is. Okay. Some of you, actually I got caught up because everybody was explaining the answer. But let me explain what is a derivative. Let's take this function, right? What is a derivative? A derivative of this function at this point. Okay. Let me just zoom out a little. Okay. Okay. This looks good. So let's take this point. Okay. The derivative of this function, derivative of fx with respect to x, let's assume at x equals to minus 2. What does this derivative mean? Again, this is just a notation. Mathematics has notation. What is the purpose of notation? So that we don't have to write long sentences. How do you read this? Derivative of this function fx with respect to x at x equals to minus 2. This is just a notation. What does that mean? Right? So what it means is at minus 2, at x equals to minus 2, look at your function f of x. What is the slope? Like at this point, I can draw a tangent. Okay, I'm not very good at this drawing because this is tilta. So I hope you all understand. You can draw a tangent, right? Tangent basically is a line, if you have forgotten that. Tangent is basically a line that touches only at that point. Okay, I'm not a perfect guy to draw this, but a tangent is basically touches this curve only at one point, a straight line that touches this. The slope of this tangent, okay, the slope of this tangent, we all know what is the slope of a line, right? Suppose if I have a line like this, what is the slope of this line? Slope of this line is tan theta, right? Again, all this I explain in the course. But since we are anyway at it, I thought I'll explain this, right? What is the slope of this line? Slope of this line is nothing but this by this, right? So if you have this line, what is the slope of this line? It is the rate of change of y with respect to x. That's what it is. Or it is basically tan of this theta. So you draw this line, you take this theta, you take the tan theta of this, right? What you get is the slope. What slope measures intuitively? Look at this. What slope measures? Again, the beauty of calculus is it all arrived from physics, but it has tons of applications. The slope here tells me how fast, if I have more slope, if the slope here, what df by dx is measuring is, it is measuring the slope of f with respect to x. Here, if you think the slope here, slope measures the rate of change. Slope measures the rate of change. That's why you use calculus in physics. Velocity is rate of change of position, right? Or change of rate of change of displacement, right? Similarly, acceleration is rate of change of velocity. So slope basically measures the rate of change of something. Now we know the slope here. Again, for those of you, for the course students, don't worry, I explain this in lot more detail. Like I spend almost a couple of hours explaining the basics of calculus later, right? For others, I'm trying to simplify it for you now, okay? I'm trying to close it down in a few minutes. Okay, so here, look at this. As I'm at -2, I'm increasing. This function is increasing at -2, right? So which means the slope will be positive, most importantly, because this function is increasing at -2. As you're going from, as this value increases, this is increasing. Hence, the slope is positive. What is the slope here? Look at this. Let's take -2. Okay, let's take -2. So let's take +2. At +2, what is the slope? How is the line? See, the tangent will be like this, which means the tangent theta will be here. Theta will be greater than 90 degrees. That's one way of thinking about it. The other way, the much more intuitive way of thinking here is this curve. How does this curve change at 2? Again, there is a mathematical way, there is an intuitive way. I prefer the intuition always. See, look at this. This curve at 2, as the value increases, it is reducing, which means the slope or the rate of change of this function, the rate of change or the change in this function because of change here will be negative. Again, what is df by dx? Think about it intuitively. It is basically, again, let me write it mathematically. It is the change in f, how much f changes because of change in x as limit delta x tends to 0. Right? Again, if you remember, this is the definition of df by dx. If you recall your 11th class mathematics, all that it says here is how much does f change? If I'm at 2, look at this idea. If I'm at 2 and if this is 2 plus delta, right? If this is my x, if this is x plus delta, right? X plus delta, let's write it x plus delta x. So this is f of x, right? And this is f of x plus delta x. What is the definition? The definition of df by dx is, what is the rate of change of this? Rate of change is nothing but f of x plus delta x minus f of x, which is nothing but the rate of, which is nothing but the change in f by delta x as limit delta x tends to 0. It is the change in f because of a change in x, but the infinitesimal change. That's the idea here, right? So if you notice at -2, as x increases slightly, f of x is increasing, which means the slope is positive here. At 2, look at this, at 2, as x increases slightly, this is becoming negative. At all these points, the slope is positive. At all these points, the slope is negative. What happens to the slope at this point? The slope at the place where you get this optima, or in our case the maxima, the slope equals to 0. That's why, I mean, if for those of you who have forgotten it, you find maxima or minima. To find maxima or minima, what do? You say derivative of this function with respect to x equals to 0. Wherever this is true, you will find a maxima and minima. But why do you find it? I don't want you to remember equations. I want you to remember the intuition. The reason this works is because at that point where the derivative is 0, you're going from a positive change to a negative change at maxima. This is the maxima, right? At a minima, look at this. At a minima, what will happen here? This is negative. The gradient here or the slope here is negative. The slope here is positive. At a minima, it will be 0. Right? So you can easily find a maxima. How do you find a maxima and a minima? You keep trying again in the interval -2 to +2. You keep trying these values. You keep computing these values. Wherever you see that the derivative is close to 0, very close to 0, that is where you have your maxima, right? And if you're going from positive to negative, as you're iterating through it in code, again, mathematically, you can say the double derivative, df by dx, dx. If this is equal to 0, this is minima. You can write the double derivatives, but how do you write it in code, right? So how do you write the code part of it? I think that's the important aspect. So to get the code part of it, you just say, I want to go from -2 to 2, and as I'm going, at every point, I want to compute the slope. At every point I want to compute the slope. I realize that the slope here is all positive. Somewhere around this point, the slope is closest to 0. Because I may not get exactly 0 here. But at some point, the slope is very close to 0. And after that, the slope becomes negative. Since the slope is going from positive to negative via 0, this point where it was very close to 0, that is a maxima. You don't have to do second derivative, all of that. Again, this question is important because this question, especially for a machine learning engineer, this question helps the interviewer understand, if you understand the geometry behind, derivatives. You might say, okay, I've done deep learning, I've done backpropagation, I've done this. I've seen people who claim that. I ask them this simple problem. I ask them, I'll give you a function f of x. Okay, I'm not going to tell you what the function is. You can just call a function, you just pass x, you'll get f of x. That's all. Now I'll give you an interval a to b. You have to find whether there is a maxima or minima, or if there exists a maxima or minima. I just tell them, please write the code for this. And I've seen tons of people fail at it because they don't understand what differentiation is intuitively. They have done I tell them, they say, I've done LSTMs, I've done this, that. But they don't have basic knowledge, which means they do not have the skills to learn more advanced concepts. The foundational skill is more important than anything else. Okay, so I hope this is clear. Okay, so let's go into our code. Okay, so the key observation, always look at the plots. The slope changes from positive to negative around maxima. Now this is cool. I already told you, right? So we know we can, again, one thing that I can do is, okay, as I just mentioned, right? So I have this curve, right? This is at -2 and this is at +2. I want to find, this is at 0, right? This is where my maxima is. One thing I can do here is I can write a for loop where I'll test it at -2. I'll test it at -2 plus some delta, -2 plus 2 delta. I'll keep testing it up to +2. At some point, look at this, at some point, at one of these points, this value will become very close to 0 or 0 itself. Very close to 0 or 0 itself. So that point where it goes from very close to 0, I also keep track of the fact that I'm going from a positive slope to a negative slope. Right? That point, again, this is a simple iterative linear algorithm. I can write a simple for loop. For x from -2 to 2, again, I'm writing pseudocode here with some increment. I can keep testing of f of x wherever f of x, sorry, I don't test f of x. I test the gradient. I have to compute the gradient at every point. Right? I have to compute the slope. How do I compute the slope now? That's the next question. So I have to write the function for slope, right? So first let's start writing things down. Okay, this is my import math. This is my f of x. We know how to write f of x now. So I will write slope of x. I'll write a function called, I want to find the slope of f of x. How do you compute the slope of x? I told you this earlier, right? Suppose if I have a function like this, right? So if this is x and this is delta x plus delta x, what is the equation for slope? Look at this. My delta has to be very small. So I'm making my delta very small. What is the equation for slope? F of x plus delta x minus f of x by delta x, as delta x tends to 0. So what did I do? My delta x is very small. What am I returning? F of x plus delta minus f of x by delta. That's what I'm doing, right? Exactly this. I made my delta very small. I've just translated this. So what slope fx is giving me is nothing but the derivative. Again, even if I don't know how to compute the derivative of f of x, look at this. My f of x can be anything, guys. I don't care. If I don't know how to derive sin x by x, I can still use this. Because I'm using the definition of what a derivative. This is df by dx at x. I'm using the definition of derivative to compute the slope. So one question that I used to ask is, I tell the interviewee that I give you a function f of x, but you can't see the code. It's in some library. You can't see the code. Okay, what it does, you don't know. Just remember that it's a continuous differentiable function. That's all I'm telling you. Right? Now you have to tell me the maximum minimum of this function. So typically people tell me, okay, let's compute derivative of this function, second derivative, all of that. I say, you don't know what this function is. I can't write it mathematically also. Now tell me, how will you solve it? So that's where this definition, this is basically the mathematical definition of what differentiation is. And that's what I'm computing here. Now I want to test. Is this true? Now I've implemented fx, I've implemented slope of fx. Slope of fx is nothing but f dash x or derivative of x without computing the derivative explicitly. That's important. I'm using the definition of derivative. Now I'm running this, okay? Print slope f of 1. Okay, I ran this, I got some answer. Cool. But how do I know that this is working correctly? Maybe I've done some small mistake somewhere. You should always test every function that you write, every snippet of code. You should always test it. How do you test it? Any suggestions? Any suggestions, guys? Oh, somebody saying, what if you have multiple maxima minima? I'll come there. Just wait for it. I'll come there, please. I'll tell you. That's a much more complex scenario. I'll come there. Please wait for it. Now, any suggestions on how to tackle this? My question here is, how do I test that again, f of x, we have already written the code earlier, so we know that it works. Can anybody help me with slope fx? Can somebody help me with, how do I test this slope f? What are the test cases? Somebody told unit testing earlier, right? What are the test cases? If I take slope f of n, I get this. But how do I know that this is the right answer? Right? Any suggestions? Maybe I've written some code. For known function, put values manually. Good idea. Very good. Good. Just change your fx. Because in this, I'm not using anything except fx, no? That's a very good suggestion. Quick learners, I'm very happy. Just change your f of x to some function that you know. Right? Some function like x square, for which you know the derivative. Because in this function, I'm not using anything except f of x. Right? So I can easily test this that way. That's one way. Again, visually if I see it, the other way, this is a jugaad or a hack. For those of you who don't know Hindi, jugaad basically means innovative hack. Okay. So I know at 0, look at this. I just plotted it from -2 to 2. I know that there is this point where the gradient should be 0. Again, gradient and slope mean the same thing. Gradient is in a higher dimensional space, right? So just excuse me, I tend to use the word gradient because I do mostly vector calculus and not scalar calculus. Again, we'll do vector calculus when we talk about optimization little later in our series. Okay, so, okay. One thing that I can do is, okay, let's just try f0. What's there? Okay, I'm getting nan. Oh, why am I getting nan now? Look at this. I said float f0. I'm getting nan. Why am I getting nan? Because fx, look at this. Because there is fx here, f of 0. So x I passed as 0. It computes f of x plus some delta, f of x. Now at 0, what happens? This is going to give me nan. So this is going to fail if I give 0. That's a problem. Think about it. Look at this. There's a bug in this code actually. That's the reason why I wanted to walk you through this case. So one thing that we should fix is if x equals to 0, we should just return 1.0. Right? Because we discussed this earlier, right? The earlier example I wanted to show you to explain about nan, but a good programmer will always say return 1.0. Because we know f of 0 from the limits that I discussed earlier, it should be 1. Now everything will get fixed. So if you actually wrote nan and not return 1, this is the problem that you will encounter later on in your code. Right? So I hope this is clear. 1 second. I want to still keep, again, this will solve our problem, I know. See, this has become very close to 0. But I still want to keep nan for a while because there is one more bug I want to show you. Because I see a lot of students doing mistakes with division by 0, nans, etc. I'll keep this. 1 second. F of 0, what happened here? Nan is not defined. Math.nan. No, return nan. That should be okay. What is wrong with this? Math.nan. 1 second. Let me see. Again, it's very, very common to get confused with code like this. 1 second. Where am I? Return is nan in math. Okay, let me just run it. Oh yeah, it's running. It's math.nan. Yeah. Again, it's very common mistake. So just be cautious of it and you'll be able to figure it out. Again, if I did not put this, the error it showed me was, okay, nan not found. Nan is not defined. So obviously it must be in math.nan, right? Most likely. That's it. Problem solved. Just try a couple of things, you'll solve it. Okay. So now, remember we learned bisection method earlier, yesterday. What did we do in bisection method? In root finding, what did we do? We took an interval. So our interval is now -2 to 2. right? Our interval is minus 2 to 2, right? What did we do yesterday? Instead of linearly searching to every value, instead of saying minus 2 plus delta, minus 2 plus 2 delta, so on and so forth, we said let's break it down. Again, the interesting part here is we know that this curve has only one maxima. If it has multiple maxima, this approach will fail, right? Again, in actual machine learning, you will encounter a problem of multiple maxima, especially in deep learning, but not so much, right? Suppose if your curve is like this, right? Suppose if this is your A and this is your B, you try to now find maxima, right? You might end up at this maxima or at this maxima. So such functions, again, we discussed this in the course also in optimization. These functions are called as non-convex functions. These functions are called as non-convex functions. They're differentiable and all that. For non-convex functions, if you have multiple maxima, the algorithms that we're discussing will either find this maxima or this maxima. There are algorithms to find all the maxima, but theoretically you can prove that they have extremely high time complexity, right? So again, there's a whole area called convex optimization, non-convex optimization, etc. We'll discuss that when we come into the concepts of optimization that we discuss later in the course. But just for intuition, if I have multiple optima, look at this. If I start searching from A to B, right? I try A. If I do a linear search, A plus delta x, A plus 2 delta x, A plus 3 delta x, so on and so forth, I'll first find this point. If I do my iteration from A to B, I'll find this point and I'll stop. If I start my iteration from B to A, then I'll find this point, right? To find both the points, you have to try everything. You have to try all the values. If you want to find both these maxima, you have to try every value. But let's assume for simplicity that there is only one maxima. Let's just assume. In such a case, why don't I use binary search? Right? I can use binary search, right? If you think about it logically, because I know that if this is my interval, look at this, this is exactly at 0, right? So, okay, so let me change this interval slightly. Let me just say this is -1 and this is 2. Okay, because otherwise you'll get 0 directly, the maximum point. So this is the initial interval that I'm working in. First I break it into two. Suppose if this is A, let's make it simpler. If this is A and this is B, this value is, let's say, A plus B. Okay, let me just teach you the generic version. Okay, at this point I have maxima. Now what I do now is this. I know that the slope or the gradient here is positive. I know that the slope here is negative, right? I know that fact. Now I can use a bisection method, which is same as binary search. We talked about bisection method in yesterday's live session, right? So what I do is, instead of A and B, see, I have this big interval, A plus B by 2. I'm sorry, A plus B by 2. This is the middle point. So instead of taking this large interval, I'll start focusing on this first part. So I compute A plus B by 2. At A plus B by 2, I say, is the slope positive or negative? The slope is negative. I can compute the slope, right? At any point I can compute using my slope of f of x. This is negative. Because the slope is negative here, I know that the answer has to lie in this region and I can ignore this whole region. That's what bisection does, isn't it? That's the idea here, right? So here, instead of looking for f of x values, look at this. When we solved root finding yesterday, we looked for f of x and we said, is f of x positive or f of x negative? Here we are saying slope f of x or derivative of f of x. Derivative of f of x is also written as f dash x sometimes, right? Just for simplicity, instead of writing df by dx every time, just write f dash x, right? So instead of checking for f of x the way we have done it in root finding, now we are solving using f dash x for this same bisection method, same concept. Look at this. Okay, let's start with this. My x lower limit is 2, x upper limit is 2, -2 and +2. Okay, so I'm starting at -2 and +2. Right? My lower limit, upper limit. So there is a curve like this. I want to find this maxima. I know that the maxima is at 0. It's easy to test. So my first x is the middle point. This is what bisection, right? Same bisection concept. All that I've done. This is same code like yesterday. Remember, we did not put absolute value yesterday. I showed you a bug. But instead of calling f of x, I'm calling slope of f of x. Because I want the derivative. Look at this. I want the derivative to be equal to 0. Right? Very simple concept. This part, this print we know, Again, look at the code here. This is bisection code that we have seen yesterday. The only change I've done here is instead of f of x, I've put slope of f of x. Instead of f of x here, I've put slope of f of x. This whole code is exactly what we have seen yesterday. Same logic, nothing changes. Same logic. Now when I execute it, I get an error. Okay, this is a fun error. I love this. This is the reason I love NAN sometime. I executed this. Look at this. I executed this code. I got, okay, so when I executed this code, the first thing that came, I got f of x here. I got x. Okay, cool. Then I got, okay, I got my answer, which is x equals to 0. F of x is NAN. I got this answer. Right? I said, okay, this looks very good. But I got my slope of f of x. Remember, sorry, I should have said slope fx here. I'm sorry. Just let me change this. I think I copy pasted code. Okay, so let me just execute it. Okay, so what did I get now? Look at this. When I executed this code, this printf statement did not run at all. This printf statement did not run at all. I directly got this statement. Look at this. My initial value is -2. Then I have +2, which means my initial value of x is 0. Right? It just computed this. No print statements. This print statement did not execute. This print statement did not execute. Why didn't they execute? Because probably this failed. So what is this? Absolute value of slope of f of x is greater than 0.001. Now in our implementation, look at our implementation of f of x. Our implementation of f of x still returns NAN when x equals to 0. In such an implementation, what will slope of f of x return? I showed you this earlier, right? Look at this. Slope f0. Look at this. Okay. Slope f0. It is returning an NAN. So absolute value of NAN is greater than 0.001. Look at what I got. Again, very common mistake again with NANs. So this I executed, x equals to 0. Before I enter into the while loop, I have to check this. When I executed this, I got NAN. Right? I got NAN now. Now I know this because I just showed you in the previous line. Now I got NAN greater than 0.001. You should never compare not a number with a number. This is like ridiculous to compare. But we compared it. We didn't handle this boundary case. Look at this. We didn't handle the boundary case that I can get NANs here. So if you actually compare, slope f0, which is NAN, if you compare NAN with 0.001, you always get false. You always get false. Again, this is something that we explained in the course videos also, as never compare NAN, but if you compare, there are these boundary cases that you enter into. Never compare it. Because it failed, you just came out of the for loop and you printed the answer. I understand x equals to 0 is the correct answer, but slope of f should be 0, it should not be NAN. Right? So there is a logical bug here that you did not handle the case that this could be NAN and you are comparing an NAN with a number. It's a major bug. So we have to fix it. So how do we fix it? Very simple. Okay, there are a couple of hacks. This is my favorite hack. Okay, let me explain the hack for you. All I do is this. Okay, again, this code stays the same. I just say while true, always true. Just we'll break the loop whenever we want. Okay, now let's look at this. I check if slope fx is NAN. If again, is NAN is a very important thing. If it is NAN, this is where I use a little bit of mathematical beauty or programming and randomization. I love, again, randomization is one of my favorite ideas in whole of algorithms and mathematics. It's, I think, the most powerful idea. Okay, so what I do here is, again, this is my favorite, to be honest with you. So I just check, first I always check, look at this. I write this condition before anything else. Is slope fx NAN? The math.isNAN tells me, if it is NAN, I'm going to change my x slightly. What am I going to do? I'm going to make my x equals to x plus random.random by 100. What does random.random give me? What does random.random give me? Just a second, guys. Just a second. Just a second, please. Okay, so let's just assume that so what am I doing here? I got an error. See, whenever slope f x equals to 0, or sorry, whenever it is equal to NAN, what am I doing here? I'm changing x, or I'm perturbating x by slightly adding a small error. What does random.random give me? It gives me a random number between 0 and 1. I'm dividing that by 100. When I divide it by 100, suppose if it gave me 0.5, I'm dividing it by 100. What do I get? I get 0.5, right? 005. I'm adding a small error or a small randomness to my x, because I know that if the slope equals to 0, if the slope equals to whatever, if the slope as I implemented, if I'm getting NaN, mostly at x plus some small delta. Again, I'm writing delta using the small alphabet delta, right? Instead of the capital delta, okay? If I just perturbate it with some random number here, if I just randomly perturbate it with a small random number here, I'll get out of that problem. So here, what am I doing here? Since if this is NaN, just change x slightly and just follow everything else. Again, this loop basically says, what does this say? This says if the slope is very close to 0, just break. Again, this condition we had it in the while in the previous. I just pulled it inside. First, I'm checking if it is NaN. If it is NaN, I'm slightly changing x using a random value. Then I'm checking is the slope very close to 0, then come out of the loop. Or else this whole loop stays the same. Again, this is one of the many ways to fix it. Now when I execute it, look at this. I get NaNs. I get NaN. But within a few iterations, I get my x very close to 0 and my slope x very close to 0. Right? I hope this is clear. Right? Again, what did we learn? We learned a bunch of things. Right? The biggest problem often in mathematical programming is NaNs. Again, we'll keep encountering this in the future also. But I wanted to show you an example. That's why I've picked sin x by x, because this is in the denominator. Ideally, when x equals to 0, please don't return NaN, return 1. So how did you decide that? By looking at the plot, by using the limits. Right? That's the key idea. But in case you have NaN, anywhere you have NaN, please handle them. Please don't compare NaNs with numbers. It's a very, very common mistake. So I'm trying to explain you common mistakes along with concepts, right? So please don't do that. Please don't do that mistake. And if you have it, always use randomization. It's a beautiful trick up your sleeve, right? So cool. My suggestion now is please compute maxima and minima of this function. Again, I'll not tell you the intervals. Please plot this. Figure out some interval where there is maxima. Figure out some interval where there is minima. If there exists a minima, let's plot it, guys. Come on. What are we doing? Come on, let's do it. Let me show you. Let me give you a small hint. Okay, so okay, x square. Okay, so this is what the function looks like. Okay, so does it have a minima? Yes, it has a minima somewhere here, and this minima certainly lies between -2 and 0. So it has a minima, right? It has a minima, and you just have to check in the interval 0. Sorry, you have to just check in the interval -2 to 0. Somewhere in between, somewhere here it has a 0. It has a minima. Does it have a maxima? Does it have a maxima? No, it doesn't have a maxima, because this keeps increasing, this keeps increasing, because x square keeps increasing. Look at this, you have x square here. As x increases, x square keeps increasing. As x increases, x square keeps increasing. Of course, sin x will keep oscillating between +1 and -1, but x square will overtake very, very quickly. Because 4 square is 16. Your 16 plus some minus value, maximum -1, won't make it any small, right? So this is continuously increasing. It will keep increasing. So there is no maxima to this. There is only minima. Of course, you can use calculus to derive that also. Okay, sounds good. Now let me go into the next problem. Again, I have more problems. That's why I hope we can. I have 3 more problems. Wow. I have this problem is simple. Let's do it, guys. Okay. So the problem is simple. Okay. I've started pre-drawing some diagrams just in the interest of time. Okay. Find if 2 circles intersect at exactly 1 point or not. Okay. So you have 2 circles. Again, all this is 2D geometry. I don't even want to go into 3D geometry. All this is 2D geometry. Right? You're given 2 circles. You have to determine whether the circles intersect or not. Whether the circles intersect at exactly 1 point or not. If the circles intersect at exactly 1 point, it is often called as orthogonal circles. Again, we'll talk about orthogonality when we discuss linear algebra. That's where we'll discuss this in a lot more detail. But I thought, let me not use some complex terminology. Let's keep it simple. Okay. So, okay. So what are the three cases? The two circles may not intersect at all. The two circles can intersect at 2 points, or the two circles can intersect exactly at 1 point. There are three cases here. Can anybody suggest how to find, you're given two circles, you have to determine if the two circles are intersecting at whether this is the case or one of these two is the case. Whether this or not this. That's what I want to determine. Any suggestions? Any suggestions? Let's go back here. Somebody says, won't the program become break even when the value of fx becomes too small? No. The previous program? No, because I'm only checking when absolute value of slope of fx is this, right? I'm not checking for f of x. Look at this line of code. This will only break when the slope of f of x is very close to 0, not when f of x equals to 0. It won't. You can actually cross check this. I'll share this with you by the end of this. You can try it. You can modify the functions and try it. No, it won't. Right? So let's go. Okay. One second. People are writing answers. I'll have to read it. Okay. It's going too fast. If R1 plus R2 is less than the distance between radii, then circles intersect. Okay, I think most of you got it. I wanted to throw in an easy problem. It's actually very simple if you think about it. It's actually a very, very simple problem. The problem is this. So take these two centers. How do you represent a circle first? That's the first question, right? We represent a circle using the center x coordinate, the center y coordinate, and the radius, right? So you have this center, let's call it center 1. Let's call this center 2. Center 1 has xyr, center 2 has xyr. You input them. If the distance between both of them is equal to radius of 1 plus radius of 2, then they both intersect at exactly 1 point, otherwise not. Look at this. If the distance between if the distance between both of them is more than this radius plus this radius, then they don't intersect at all. If the distance between this center and this is less than R1 plus R2, they'll intersect at 2 points. That's it. Very simple problem, right? Right? So very simple. I mean, it's literally 5 lines of code. Okay. So somebody asked me about input, right? We discussed about Python 2, Python 3 in the first live session. So I ensured that we are in Python 3 now. I wanted to show you the input function once again. That's the reason I picked a simple problem. Okay, this is trapezoid method. Go down. Okay, so we are here. So all I'm doing here is, again, please understand this. Map is a beautiful tool. Okay, map is a beautifully elegant tool in Python. It's an inbuilt function. I shouldn't call it a tool. I should call it inbuilt function. Map is inbuilt function, right? What does it do? So first, it executes this. Okay, input circle 1 dot split. So what does this do? Look at this. My input takes in the input. Suppose if I input, let's say 3.0, 0.0 and 3.0. When I input this, what happens? It is reading this. The input reads it as a string. The split splits this into 3 strings like this. Okay, it is splitting this into 3 strings, right? Now, what it will give me is a list of strings. Now, on this list of strings, what map does is, on each of these lists, look at this, on each of these strings, it will apply the float function, which is a typecasting function, on each of these entries, and it will return that. Okay, right? So for those of you who don't know map, it's one of the most beautiful things. We explain it in our course videos. But if you don't know that, let me show you the documentation. Always documentation is God. Okay. So what does it say? Okay, map says my first parameter has to be the function that I want to call. The second has to be an iterable object. We know list is iterable. So how does it work? If you give me an iterable, if you give me a list, if you give me 1 string, 2nd string, 3rd string, it will apply this function on each of these and it will return the output. Right? Again, you can read the whole description and that's what it does exactly. Okay. Again, map is a beautiful function, inbuilt function. Map is, by the way, inbuilt in Python. I mean, this is one of the most widely used. I mean, if you see open source code, people use this left and right. Again, I think in one of the previous live sessions, one of the students suggested this. So I thought I'll put it here because it was a very good suggestion. So I get my circle 1, I get my circle 2. Now all I do here is I want to compute the distance. We know how to compute the distance between 2 points. We discussed this in one of the previous live sessions, right? Center 2x minus center 1x square, center 2y minus center 1y squared, square root. I'm done. If D12, if the distance between circle 1 and circle 2 is equal to circle 1 radius plus circle 2 radius, print this, or else don't print it. Very simple. Again, you can test it. I've intentionally given these circles so that they intersect. You can try this. Very simple code, literally 5 lines of code. Right? One input. Again, if you just skip the prints, one input, you can skip the print. 1, 2, 3, 4, 5. 7 lines. Okay, sorry, not 5 lines, but 7 lines. It's that simple. Now let me complicate it and give you a problem. Okay, so the problem now is, imagine the 2 circles are intersecting and you can easily determine this, right? This is one circle, this is another circle. Let's say this is circle 1, this is circle 2. You can easily determine, I just discussed how to determine this, right? Take the distance between both of them. If D12 is less than R1 plus R2, then you know that they're intersecting in 2 points. Now I want you to find these 2 points where they intersect. Given the circles centers and radius, I want you to find the coordinates. Again, think about it. It's not rocket science. This is high school math, guys, to be honest with you. Okay, this is simple high school math. Please try to figure it out on your own. What is the coordinate where they intersect? What is the coordinate that they intersect? You are given the centers. Again, sometimes you're asked these very, very simple problems because interviewers, again, I've seen people ask such a question in interviews. The reason such a question is asked is because people want to see how you think step by step, how you think mathematically step by step. Because for a machine learning engineer, tomorrow he has to read more research papers. He has to think clearly from a geometry standpoint. Now, how can they think geometrically if they cannot do a very simple geometry problem? Again, this is not rocket science. Again, this is, I think we solved this in 9th or 10th class. When we learned coordinate geometry, we solved it, maybe 11th class. Again, I'm providing you a link here with a worked out example, but please don't see this link. Try to figure this out on your own. Now, then write a program. It will also be like no more than 10 lines. Write a program where if you're given this center and radius, this center and radius, this center and radius, you output these 2 points. Very simple. Please try to think about it. Try to solve it on your own. Simple puzzle, right? Nothing very complex. Okay. 7:30. Okay, I think we can finish the next problem. Anything that we cannot finish today, we'll postpone it to tomorrow. Okay. Okay, this is a very good problem. I love this problem actually. Okay. So print the first 10 digits of a factorial of a large number. Okay, so again, okay, I'll tell you the history behind this problem. I was asked this question when I interviewed with Yahoo Labs straight out of my MTech. This was an interview problem that I was personally asked. And the way it worked was they did I think 4 or 5 rounds of machine learning, and they took us to the Yahoo Labs office and they said, okay, guys, here is a computer in front of you. The computer has C, C++, Python, Java, Ruby, all the major programming languages. If you want to use the internet, that's okay, but please don't copy paste. Oh, sorry, we were not allowed to use the internet. I'm sorry, I forgot. They said any programming language is okay. I don't care. But the problem given to us was, given a large number, let's assume I'm given a number like 100 or 200. They said the factorial of this number, I want the first 10 digits of the factorial of this, because the last 10 digits will mostly be zeros. You can think why. They said the first 10 digits we want you to print. And the fun part was we were given like what, half an hour. So first they asked us, okay, think about the solution, come explain it to one of the teammates. And then once you explain it to one of the teammates, we'll let you code. You can code in any programming language, but we want a working code with the algorithm, everything in under 30 minutes. And you have to show us the output. This was long ago. This was like in 2009. But this shows you, again, Yahoo Labs was literally the best place to work straight out of college because they were building Hadoop based machine learning in 2009. So it was literally the bleeding edge of machine learning in 2009, at least in India, right? So I was fortunate, I got lucky, I got in and all that. Again, I wrote the code. I remember I was so bad at programming at the end of my MTech because I did pure theory work. I said, can I write code in MATLAB? My interviewee, still a good friend of mine, he said, no, you can't write it in MATLAB. We don't have MATLAB. You can write it in C. I'm sure you have not forgotten C. So I actually wrote this code in C programming language. And thankfully it worked out okay. Okay, so the interesting part is, let's try to do that in Python. Okay, so Python has a very interesting thing. Actually, I didn't realize it. So first, let's write it down. Okay, so this is actually a real problem that I was personally asked almost a decade ago, but still a good problem even today. Problems don't become trivial, right? Okay, so let's see. So I just wrote my factorial like this. It's an iterative algorithm, very simple. Fact10, r equals to 1 to n, right? R star this, factorial 10. Okay, I'm getting factorial 10, very good, no problem. Let's just check if the code is correct. What is factorial? Okay, factorial 5 is 120, we know that, right? So, okay, the code is working well. I didn't test it earlier actually. Okay, factorial 10, we are getting it. Then I typed fact 100. It is printing this bunch of digits. My first question was, then I said factorial 1000. It printed all these digits. I said this question is useless now because Python actually is doing it. Then I started reading. Actually, I didn't know that it would do it. I thought Python would use a data type like an integer or a long, if you remember. All these are data types in Python, right? And it would have a limit. It can't store more than some bunch of digits, right? So it will overflow, it will give me some error, all that. It didn't give me an error. Then I started reading the documentation, right? So I found this brilliant blog which explains why such an error is not happening, right? It's a very good blog. It tells you that this is a Python internals blog. Sometimes if you, again, it is instances like these that will teach you to read Python internals, how Python works internally. So this is Python 3, I think. Yeah. So this is how Python stores numbers. Again, Python internally uses C. Python to store numbers internally uses C, right? So this is the C structure. Those of you who know C, this is how Python internally stores numbers. Okay. Again, people who go into Python source code, or I should say Python implementation of int, the source code behind Python, those people will know it. So very interestingly, since Python 3, there is no longer a simple integer type. All integers are represented as big num. Look at this. This is an important statement. Okay, all integers are represented as big num. So then my question was, what is big num? You start reading. Again, I want you to read this. This is all internal implementation. This is Python internal implementation. How Python stores the data internally using C. At the end of the day, C is like a beautiful language, right? So there is all these beautiful internals. If you have time, please read it. But the lesson learned was, Python uses big num right now, and it can handle arbitrarily large integers. If the integer initially was only 10 digits, then I multiply it with something and it becomes, let's say, 12 digits. It will automatically, it can do arbitrarily large number of integers from Python 3 onwards, right? So big num is a concept in programming which says that, okay, let's not create any artificial limits to integers. Let them grow as long as I can store these digits, in my RAM, let it keep growing. Why should I stop it? Right? That's the idea. Now, okay, then I said, okay, this is cool. Things are much easier now. But then, what if such an implementation is not there? What if? Let's take a case, right? What if Python does not allow arbitrarily large integers? Let's assume Python's, again, I'm using an integer here, right? Because I don't mention the data type here, it will be an integer. Again, you can check the data type always. So if you print type factorial 1000, you get int. It belongs to class int. I told you what is class, right? Internally, the integer is remembered as a class. Okay, that's the interesting part. Now, what if big num did not exist in Python? What if we did not have it? Then how do we do it? Right? So what I mean by that is, imagine integers, imagine the programming language you're using. Okay, an integer cannot be more than, let's say, 10 digits. Let's just say, I'm just creating an artificial limit here. Okay, some 10 digits, or it has to be less than some number, something like that. In C, I mean, there are strict conditions. If you write code in C, this will break. right? So Java also has something called as a big number, but Java integers will break, right? So imagine if Python also had this limitation. How would you now solve this problem? Any suggestions? Any suggestions? Okay. What if it is defined as recursive call? Even if you define it as a recursive call, it's a problem, right? At the end of the day, look at this. Suppose if you write fact n, you wrote it using recursion. At the end of the day, if you are storing it in a data structure or a data type, which can only store 10 digits, very quickly the factorial, again, you have to keep calling this factorial function, right, over and over again. If the variable that you have, if the data type that you have, or the variable that you have, if it cannot cross 10 digits, it can't store it. If you use a programming language like C, C++, Java, many of these programming languages, it gives you something called as an overflow error. What it means is I can't store such a large number here, right? So you can try it with recursion, it will fail, right? So it will fail, trust me, you can try it. I wrote, again, recursion has its own headaches. Recursion is not the most optimal solution always, but even if you do it, okay, so let's assume that in Python, just for simplicity, Python 3 has made our life simple, but the way I twist this, I've asked this question to others also, right? I've asked this question to others as a simple programming exercise. Okay, so somebody says, okay, so people have some ideas. Okay, let's see. Okay, linked list. Okay, that's good. Okay, somebody says somebody is using data structures here. Cool. You're using a list. Again, for those of you who don't know what is a linked list, that's okay. You can just look for what a list is. That's okay. Okay. Think of linked list as a slight expansion on the concept of list. Okay. Somebody says we can use a linked list. That's a very good idea without doubt. But let's say we can use lists. Okay. Somebody says A by B equals to quotient of A percentile A mod B, which is equals to remainder digit of num being added to blah blah blah, all that. Okay. Create the list of digits of the factorial. We can round it. We can use matrix or array. Yeah, we can use matrix, array, list, doesn't matter, don't worry. Typecasting to big int. Even big int, long int, all of them, right? They'll have some limitation. If I want to compute 1000 factorial, the number of digits is like massive, right? So big int, long int, let's assume no inbuilt data type can handle the maximum, the use long. You can use anything, right? Long also. How many digits can long store? 30 digits. I don't know. I'll have to test it myself. I don't remember this at the top of my mind. Whether you use big or big int, whatever, it will have a limitation on number of digits, right? Suppose if my n factorial with n equals to, let's say, 1000, right? So n equals to some 10,000 has some 20,000 digits, right? Suppose if it has too many digits, you still can't store it in bigs or big int or long int, none of them. How do you use, somebody says dynamic programming. How do you use dynamic programming, dude? Somebody says, can we use log? That's an ingenious idea. I thought of it. Good. You can use log, yes. But again, log also will run into some problems. Look at this. Okay, so it's a good idea, Ramesh. I'm thinking, I like the thought process. So his idea here is this. If you have n into n minus 1 into n minus 2 into so on and so forth up to 1, okay, this is what you want. This is the result. Your result is this. So he says, let's take log on both sides. Okay, log r equals to log of this whole thing. This whole thing I can write it as log of n plus log of n minus 1 plus, because log of product, so log of product of things becomes sum of logs, right? Plus log 1. Cool. Suppose I can compute log, I compute all of them, right? So what do I get? I get some number. Let's say I get some number x. So my log r equals to x. Now I want r. How do I compute r? R equals to e power x. Now how do you compute e power x now? How do you compute e power x? X is so large. Remember, your x itself will be quite large. That e power x also can't be computed because no data type can store e power x temporarily. That's the problem here. But it's a good idea. I like the thought process. But it doesn't work in this case. It's a good idea. Because I remember thinking of log when I was solving this problem almost more than a decade ago. Okay, linked list is the solution. Yes, let's try strings, blah, blah, blah. Ignore multiples of 5 while calculating factorial. Okay, return it and store it as a string, print only 10, blah, blah, blah. Okay, I think some of you got the answer. I'm happy about it. Look at how we did it as kids, no? So if you have 236 multiplied by 4, how do you do it? You multiply this digit, 6 4s are 24, 4, you store 2 here, 12 plus 2, 14, 1, 8 plus 1, 9. So store each of this, look at this, just create an array. You can always resize arrays, or you can store this in a list, you can store it in an array, whatever data structure you want. You can store it in a linked list also. For those of you who are suggesting linked list, you can store it like this, 9, pointer, 4, sorry, my bad, 4, pointer, 4, null. You can also store it using a linked list. Those of you who know what linked lists are. You can store it in an array. You can store it in a list. You can store it in a list. All you have to do now is you have to redefine your multiplication. The simple multiplication. So if you have two variables, the multiplication that is in the multiplication operator that is there in Python will not work. So you'll have to write a function called mul. Look at this. So I hope you got this, right? This is how we all do it. Even if you change it to hexadecimal, anything, the same problem occurs. You can change it to binary also. Doesn't matter. All this problem continues, whichever encoding you use, right? It doesn't matter. The problem stays the same. So let's solve it in decimal because all of us understand decimal. So what we have to do here is we have to define a function called mul, which will take, let's assume I'm using arrays, okay, which will take an array as an input and which will take another number, right? Let's call this array as A. It will take B as input, and what should it return? It will now multiply A with B by going iteratively. Again, you have to write a for loop inside this. I'm not writing the solution because I want you to write it on your own, but I'll give you the intuition. In here, what do? Again, we are representing a number using an array. If the number of digits increases, you just create a new array and store that, delete the old array or resize the array, right? Suppose I have A here, some 236, and my B is 4. I want to multiply both of them. So what do? I write a for loop. I write a for loop wherein I first get 6. How do I get 6 here from 236? 236 mod 10 gives me 6. Or mod 10 power 1 gives me 6. Right? 236 mod 100 gives me 36. Look at this. 236 mod 100 gives me, okay, actually I don't even need mods, no, I'm sorry, because this is in an array. So first I take the first element of the array. So let's assume this is 0, 1, 2. I take the last element, 6. I multiply with 4. What do I get? I get 24, right? 6 4s are 24. So my loop will go from the last element to the first element, right? My loop will go from 2, 1, 0. This is how my loop will be, right? So this is how again, I'm not writing the code here. I want you to write the code. My loop will go from the least significant digit to the most significant digit. I multiply my B with the least significant digit. Whatever I get, I paste it here. I keep carrying. So the same thing that we did, right? 6 4s are 24. The carry, I'll copy it somewhere. I'll create a variable called carry and copy it here, right? Carry is 2. Then I multiplied with the last digit. Then I multiply with the last but 1. 3 4s are 12 plus 2, 14. So 4, my carry is 1. 4 2s are 8 plus 1, 9. I got 944. So now my result is also an array of size 3, right? So what do I do here? I take this array, I modify 236 to 944, right? And I return 944. Or I can create one more array. Again, just make sure that you're deallocating memory. You're removing arrays from memory. You're just clearing it. Just ensure that you're clearing up memory, right? So that's all there is. Please increase the zoom on your screen. I hope I'm writing it in a very big font, no? I hope this is okay. No, so I don't want to use linked list because you don't need it here. You can also do it using linked list. It's the same code, no? The logic is the same. The logic is if you want to write this in C, you can always store this as a linked list with the least significant digit here. Suppose if I want to store 236, always store 6 here, then 3 here, then 2 here, right? Because this is a singly linked list which you're starting from here to here, right? So what doesn't increase the time complexity? Doesn't it increase the time complexity? What increases the time complexity? I didn't understand this. Anyway, so I didn't understand. Okay. I don't know what you didn't understand. So it's very simple, no? So the code that I explained you here, see, you basically replicate this. Logic is the same. Again, I'm trying to explain the logic. Your implementation, if you want to write it in C, the implementation will be different. You can write doubly linked list, whatever you want to do it, guys. Doesn't matter. You can use an array, you can use a list, you can use a linked list, a singly linked list, a doubly linked list, doesn't matter. Okay. If I were writing this code in C, I will most likely write it using doubly linked list or singly linked list. If I'm writing it in Python, it doesn't matter because I can resize my arrays in Python dynamically. Python gives me a lot of flexibility. I can also resize my list. If I'm doing it in Python, I can do it using arrays and lists. Why bother about singly linked lists and doubly linked list? We don't know the size of the array. Good question. That's why I'm saying So let me give you an example. Imagine if my number is 544. Okay. You can read this as an array. You can think of it as a list or a linked list. Doesn't matter, right? Now this you multiply, okay, with let's say 6. When you multiply with 6, what happens? Okay. So my input here is, let's say, an array of size 3. This number is here. So what do I do? 6 4s are 24. 6 4s are 24. 24 plus 2 is 26. 30, 32. So what is my output now? My output is not an array of size 3. It's an array of size 4. So what do I do? To save space, I create an array of size 4, right? And I clean up this array from memory. I deallocate this array from memory. And I return this array now. Now somebody is asking, how does this connect to the problem? Okay, so let me explain this. I think you couldn't connect the dots, but let me explain this. So what is the problem here? You started off with, you want to multiply, let's say I want 1000 factorial. Suppose I want 1000 factorial. How do you get 1000 factorial? You multiply 1000. You start with 1 first. Okay, you start with 1. 1 multiplied by 2. You always store your results in an array or a list or a singly linked list, whatever. 2, right? So you got 2, cool. Now you want to multiply 2 with 3. But instead of multiplying 2 with 3, you just call this function mul with 2, 3. What does this function return? This function returns, again, an array, linked list, whatever way. Again, I'm going to assume that you're storing everything using an array, and arrays are resizable in your programming language. If they are not resizable, please use a linked list or a singly or doubly linked lists, depending on your programming language, right? So you got 6 now. Now again, you will call mul 6, 4. You'll keep calling this, right? So my for loop will be fact n is, my for loop will look like this. Let me change the color slightly. My for loop will look like this. Fact n is for I equals to, okay, I'm writing pseudocode here, right? For I equals to 1 to n, right? Mul, okay, so first I have to create this array, right? So for I, so my result, I'll have to create a result first. Okay, let me write this down. Let me write it on a fresh sheet. I think that's better. So fact n is my function. First I create an array. Okay, so my result is, let's say, an array. I'll just create it, let's say, array of size 10. Okay, I'll create some array of size 10. I'll start with size 10. I'll initialize everything to zeros. Okay, I'll initialize it. Simple. Now I'll say for I equals to 1 to n. Again, I'm writing pseudocode here, not Python code. Okay, you can easily translate this to Python code. Okay, r equals to, okay, so I'll have carries also all the time. Carries will initially be 0. So, okay, carry will be 0. Okay, so let's do this. Okay, r equals to, okay, let me do this. So what I want here is, okay, I don't want this also. So my mul function is defined as follows. Okay, my r comma c, my result, and if there is a carry. If there is a carry, if my result is more than 10 digits, this is basically an array of size 10, right? If my result in this loop, if I get a result which is more than 10 digits, if it's more than 10 digits, I'll get my carry. So I'll say mul, right? What am I passing here? Mul R, so my R I'll initialize to 1 instead of initializing it to, so mul I'll initialize it to 1, right? So my R, so mul R comma I, right? So here I don't have to do 1 to n, I'll just say 2 to n. So what does this result in? This returns, look at this, what does it return? It returns, again I'm passing R, so it will modify R itself. So in the mul function, my R gets modified. My R, whatever is the initial value, it gets multiplied by I, right? The result is stored in R. Okay, instead of doing that, right? So the result is now stored in R. Again, I'll have to output two things. I'll have to output an array and a carry. Now, if this multiplication crosses this, if this multiplication cannot be held in 10 digits, what do? If my carry is greater than 0, that means I got a carry from this multiplication. Then I'll create new memory for R. Look at this. Because 10 digits were not sufficient, I'll say whatever is the size of this, I'll double the size. Then I'll get a bigger array now. Right? And whatever were the elements here, I will copy all of them to this. And you keep doing this. Right? I hope, again, there are pieces in this to be realized. The reason I'm not writing the actual code, what if there is more than 2? Anyway, I'll come there. So first, the reason I want you guys to figure this out. Imagine if there is no big num, how do you solve this problem? I want you to figure it out. Again, there is solution available. What I want you to do is this. Please do not see this solution till you have the solution or you have spent at least 3 hours on this problem. Again, the reason I want you to spend at least 3 hours is after explaining the logic, it will take you some time to figure out how to allocate memory or how to allocate an array, how to deallocate an array, all of that. A lot of which we have covered in the course videos, but I want you to figure it out. If you don't know, just Google search for it, right? It's just a Google search away. How to reallocate, so there is also this concept called reallocating memory. So reallocate memory Python, right? So you can always, memory allocation is an important task here. So this task, again, depends on your implementation, but if you know memory allocation and reallocation, this is trivial. I want you to figure it out. If you are not sure, the solution is available here, but please don't look at the solution till the time you have spent at least 3 hours on this problem or you have found the solution yourself, right? I hope that is clear, right? We are 7:49. We have one more question. Mul is multiply. Yes, mul wants to do multiply. What if we get a carry from multiply? That's what I told you, right? If you get a carry from multiply, you assign a larger array now. You basically take this array. R is made of array. Look at this. R is made of an array of 10 elements. You now create a new array. Again, call it R. Or you reallocate memory. You reallocate memory for this array. Instead of size 10, make it size 20. Double the size. Or just increase the size. If you get a carry, what does it mean? It means the data is not, you're not able to fit that in this array. So what do you want to do? You want to increase the space, and again, don't forget to copy the carry in the increased space, right? Don't forget to copy the carry in the increased space. Again, this problem is all about memory allocation and deallocation. Memory allocation and deallocation in Python. If you're not sure, just read up about it. If you know it, it should be simple. Why R taking 1 in last? Where is R taking 1? Oh, this one, because if you take it 0, multiplying anything with 0 will give you 0, no? That's why I put it 1. I told you, right? So what does this result? It will multiply R with I and place the result in R itself, right? So this is exactly this. So that is exactly equivalent to this code, the iterative code that we wrote, no? Oh, look at this. Why is R equals to 1 here? It's the same logic. If R equals to 0, somebody was asking this question, right? If R equals to 0, you got to answer 0. Because you're multiplying everything with 0. In factorial, you don't multiply things with 0, no? So that's the reason. Okay, so there is solution available, but please spend some time. Again, we have one more problem, very interesting problem. I want to finish this. I hope you can spend 15 more minutes on this. I promise you I'll finish this problem, okay? Everyone okay with that? Is this classes are for people, whoever are, what is, Yeah, you can use in what if we use list and delete the old one? Yes, you can do that. It will just create more. I mean, you can do it. Nothing stops you from doing that, right? Yeah, you can do that. Not a problem. Is this classes for all people or those are just for demo? So the purpose, again, Santosh, I think you didn't get the purpose. We made it an announcement, right? So the basic Python videos and Python problems, I wanted to share it with everyone. That's why they are publicly available. But the idea here is that I'm assuming that you know basics of Python. I mentioned this in the previous sessions also. If you do not know Python, you may not understand a lot of what I'm discussing in this live session, right? So I'm assuming that you already know Python. So how will you get carry? You can, of course, that depends on how you implement your code, no? You get carry because you have to implement your mul function. This mul function you implement such that if the result cannot be fit in R, you output you output C. Again, functions can output multiple values. If you're not sure of that, please read up about functions that can result multiple values in Python. Functions can do that. Okay, it's a very simple concept. Just Google for it. Functions can return multiple values if that's your question, right? So let's go to the last question today. Again, this is the last question in mathematical programming. This is a question that was asked to one of our students recently when he was interviewing with IBM Research. It's a very popular question. The question here is, you have to estimate the value of pi. All you can use is the formula of the area of a circle and the circumference of a circle. We all know this, right? The area of a circle, we all know that the area of circle is pi r square and circumference is 2 pi r. We all know this. This is the only definitions that you can use. Of course, if you're an engineering student, pi, there are infinite series expansions of pi. You can't use any of that. The problem is simple. You have to estimate the value of pi using only two factors, only two concepts. That the area of a circle is pi r square, that the circumference of a circle is 2 pi r. Right? Again, those of you who don't know, pi was initially defined in the ancient world as the ratio of circumference by diameter. Diameter is nothing but 2r, right? So the definition of pi is the ratio of circumference by 2 diameter. That's the mathematical definition of pi. Pi is not 3.14. This is the definition of pi. 3.14 is an approximate value that pi takes, right? So you can only use these two facts and you have to estimate the value of pi. It's an actual interview question. Actually, it's a simple question. It's not a rocket science question, but it's a good question. I like it because it's a very apt, again, this was asked for a machine learning engineer role at IBM Research, not IBM Development. This is IBM Research Labs. Okay. No, you can, given any circle, somebody says 22/7, come on. It's not that simple, right? So, somebody says, do we have area and circumference given? Yes. You can take any radius and you get area and circumference, right? Is this intermediate Python? I don't know what intermediate Python means. I'm just assuming that you know the basics of Python and I'm solving a bunch of problems. Again, I never understood when people say advanced Python, intermediate Python. I think these are definitions created by people just for the sake of it. I don't know what is intermediate Python, to be honest with you. Okay. I don't agree with you in the condition that if C is greater than 0, reallocate memory. Again, there are multiple ways of solving the factorial problem, the earlier problem. It's up to you. There are multiple ways. All that I've shown you is one such way. You can define it in multiple ways. Again, please feel free to write your code and make it work. That's all we care about. Assume value of area and circumference. Okay, area is, you're not, no, one second. Area is, okay. So you are assuming that somebody gave you both the area. Okay, I know where you're headed. So the assumption, somebody was making a good, interesting way of looking at it. Somebody said that, okay, imagine if for a circle I'm given both the area and the circumference. Then how do you compute it? Oh, you can do it. You get pi square. I know it. No, that's not what I meant. Okay. So if somebody gave you circumference and area of a circle, right? They already computed this. Then he's saying I'll take C square, which is 4 pi square r square divided by area, which will make it pi r square. So r square gets cancelled, pi gets cancelled, I get 4 pi. So I'll take this, I'll divide it by 4, I get pi. I know where you're going, but that's not the intent. You're given the formula for, you're given the formula for area and formula for circumference. That's all you're given. You don't have to derive them from first principles. Again, deriving them is not so easy. Okay. I mean, it's a good interview question also, especially. So one of the interesting question is, the definition of pi is circumference by 2r. This is the mathematical definition. Using this definition, prove that the area of a circle is pi r square. Who told you this? How did this come to? We all were taught in our, I think, 6th grade, 7th grade, that this is the area, we all remembered it by heart. Right? We all just remembered it, no? This is the definition. This is the definition of pi. So definitions we have to remember. But can you arrive at the formula for area? Again, that's a good, interesting question. It's not hard. It's just 11th class mathematics, or actually even 10th class math. Anyway, I'm not going there. So you're just given the formula and you have to figure it out. Some of you have told the answer. I'm not pointing them right now. Find area by trapezoid rule and divide by r square. Oh, that's an interesting idea. Very good. I love this idea. Oh, wow. This is good thought. How do you find the area using trapezoid rule? Haha, okay. So you're writing the equation of the curve. Okay, I got it. Haha, so you're saying I'll find, okay, so let's take semicircle. Oh, this is a good idea, Arun. I should, Arun, good idea. So your idea here is, we know the equation of the circle. So let's take the semicircle. Let's compute this area. Interesting. Using trapezoid rule. Cool. So you get the area using trapezoid rule. So area of the semicircle is pi r square by 2. So this area you computed using trapezoid rule. This area is this. You know what is the radius anyway. So you'll say 2a by r square will be equal to pi. Cool. That's one idea. Very good. This is interesting. I mean, I didn't think of it, to be honest with you. Yes, that's cool. I don't know if others have also suggested it. Arun, very good suggestion. Okay, this is one way. Wow, I didn't think of it. Okay. Probably if I asked this question in my interviews, I would have learned more ways. But cool. I like this. Anything else? Yeah, I got it. I got Arun. I got it. I got the point. Okay. Integration, interval. Okay, same. Using integrations, all of that. Somebody mentioned, okay, Pratik mentioned, can we use Monte Carlo approach? That's a good idea. So let me introduce you to something called as Monte Carlo approaches. I want to introduce a concept also. The concept is simple. Okay. Again, the ingenious idea is use random numbers. Okay. So let me explain. Those of you who don't know, again, Monte Carlo sounds like some advanced math. It is common sense. Okay. So we have used Monte Carlo methods in our course videos also. So in our hypothesis testing chapter, those of you who have seen that, we have talked about permutation tests. So we have talked about permutation test, if you recall, in our hypothesis test in probability statistics. Permutation test is one of the ways of using Monte Carlo approaches. Monte Carlo approaches is a big area in physics. Again, this came from a bunch of brilliant mathematicians. The idea is simple. Okay, the idea is to use randomization. Again, I'll provide you some reference links, but let me tell you the approach instead of telling you the theory. The approach is this. Imagine I have a circle like this. First of all, let's draw a rectangle. Okay, let me change the color here. Okay, I have a rectangle here. Okay, this is a unit rectangle, which means this is width is one, square, not rectangle, I'm sorry. Anyway, a square is also a rectangle is also a square, so it's okay. So it's a unit square, right? This side is 1, this side is 1. Within this unit square, if I draw a circle, what is the radius of this circle now? What is the radius of this circle? The radius of this circle will be 0.5. What is the area of this circle? Okay, first let's say what is the area of the square? Area is equal to 1. What is the area of this blue circle? Area of this circle, your r is 0.5. So pi into r square. What is 0.5 square? 0.25, right? Which means by 4. This is the area. So first observation, right? First observation is the area of this circle, right, is pi by 4. So suppose if I take, okay, let me just name these things. Okay. So let me just name them. So area of the square and area of the circle. Okay. So if I do area of the square by area of circle, the other way around, sorry. So if I do area of circle, if I do area of circle by area of square, what do I get? I get pi by 4. So 4 times this, what do I get? I get pi. Right? 4 times. Just simple. Area of square is 1. Area of this circle, again, this square and this circle is pi by 4. So 4 times area of this circle by area of this square, because this is 1, no? 4 pi into 4 is pi. So this is one fact. So let's write this down. Right? 4 times area of the circle by area of the square equals to pi. That's a fact. Let's keep that. Very important fact. Now what Monte Carlo approaches tell you is this. Okay, very ingenious. Okay, they tell you, what if I have a way of throwing random darts? Okay, what is a dart? Okay, let me show you what is a dart. Okay, it's better to show you in image search. Images, okay, or just let me do dart. Okay. Darts are these. Okay, this is a dart. Right? You know what is a dart now, right? So the thing that you throw. So imagine we have a way. Suppose this is the board. I'm throwing darts. Suppose I am a random dart thrower. Okay, important. Imagine if I'm randomly throwing darts, but I'm randomly throwing them such that all the darts fall in this region. Right? All the darts or all these arrows that I throw. Let's just use the word arrows, right? All the arrows that I throw are guaranteed to fall in this square. Some of them will fall in this region, some of them will fall outside this region. But remember, this is a random dart thrower. What is a random dart thrower? The chances that it will fall anywhere is uniform. Again, we'll discuss about uniform distributions later. It can fall anywhere in this region. Anywhere in this whole region. So it can fall anywhere in this whole region with same probability, but it is random. It can fall anywhere. That's why the randomness, right? So that's why the randomness. It is guaranteed to fall in this region, right? Some of them will fall in this, some of them will fall outside this. But the throw itself is random. Now, how do I generate a random dart or a random arrow? Using random numbers. Imagine if I create 2 random numbers such that this random number is a random number between 0 and 1. This is also a random number between 0 and 1. Okay, this is a random number between 0 and 1. This is also a random number between 0 and 1. Wouldn't that be equivalent to, and whatever coordinate that I get? Okay, so what did I do here? I took two values. This is random number generated from 0 to 1. This is random number generated from 0 to 1. This corresponds to the x-axis, this corresponds to the y-axis. Now, if I generate 2 such random numbers, I get a point, right? So I can use this point, which is generated randomly. This is a 2D point randomly generated. Why is it randomly generated? Because this is randomly generated from 0 to 1. This is also randomly generated from 0 to 1. Because this is from 0 to 1, this is from 0 to 1. I am guaranteed that this whole thing falls within this square. It is guaranteed. It is guaranteed that the whole thing falls in the square. But it is also guaranteed that because they are generated using random numbers, this is the beauty of Monte Carlo approaches. Because they are generated with random numbers, the number of darts, suppose if I throw some 10,000 darts or if I throw 10,000 arrows, what percentage of them will fall within the circle and what percentage of them will fall outside the circle? That's the idea here. Look at this. Because the dart can hit anywhere in this square randomly, right? Right? So suppose if n is my number of throws, suppose I've thrown 10,000 times. Let's assume of these 10,000 times, some m times the dart fell within the circle. We can verify whether the dart fell in a circle or not, right? Very simple. Take the distance between both of them. If the distance between both of them is less than equal to this radius is 0.5, then I know that the dart fell within the circle. Very simple. If m, see, look at this. Of the 10,000 times, if m times it falls in the circle, this m is proportional to the area of the circle. That is the leap, right? Because you're throwing it, you look at it, you're throwing a dart, you're throwing. Because this covers some area. How much area does this cover? It covers pi by 4. What is the total area? Total area is 1. Because this covers area of pi by 4, this ratio will be same as the ratio of m is to n. Look at this, this ratio will be same as this. Because my dart thrower is random. Within this region, he's throwing randomly some darts. Right? So now what I do here is I create a simulation. Okay, Monte Carlo, these are also called as Monte Carlo simulations. Because what am I doing here? 10,000 times, I'm generating a pair of random numbers and calling it a point. Let's call this a point P. 10,000 times I'll randomly generate. For each of these points, I'll compute whether it's in the circle or outside the circle. Right? 10,000 times. I'll keep counting. My m is basically a count. Which will count how many times out of this 10,000 times this fell within the circle. Right? Very simple. Now I know that pi by 4 is to 1 is same as m is to n. And I know n is, let's say, 10,000. Now I already, using the simulation, I can measure how many times I got it here. This ratio is pi by 4 to 1. Right? This ratio I know already. Or you can write this ratio also as pi is to 4. Now here I got 10,000 times. This ratio is same as this ratio. Right? Suppose I got some m times here. Now since this ratio should be equal to this ratio, pi by 4 should be equal to m by n. Right? N equals to 10,000 now. Now I know 4 is a constant. I got m through this simulation, through this random simulation. N is the number of times I threw the dart. Using these, I can compute pi. So this is what is called as a Monte Carlo simulation. It's a fancy name. Again, Monte Carlo simulations are a beautiful topic in mathematics. Physicists typically study it. And okay, so let me show you this. So these are approximations of pi. I'm sorry. There is Monte Carlo simulation somewhere. Okay, so here is a Monte Carlo simulation. Okay, so this is a Monte Carlo simulation. It explains what is a Monte Carlo method, all of that stuff. Again, the classic example. This is how it's taken. Instead of taking a whole circle, they just took a 1/4 of a circle. They're randomly generating points. They're seeing how many points, again, very nice simulation. All that they're saying is how many points lie within this quarter circle. This is a quarter of a circle, right? How many points are lying outside of it? Based on that, they're getting it. So a Monte Carlo approach basically says, first define the domain of possible inputs. Again, it's a very general method. It's used in so many places in physics, in mathematics, computer science, etc. I told you, right? Permutation testing is one example. So if you go to applied statistics, look at this. They clearly mention this. Where is it? Okay, so to provide implementations of hypothesis tests that are more efficient than exact tests, such as permutation tests. Again, permutation test is one example. There are other distributions also. So this whole area, Monte Carlo methods, are a very broad topic. We are just using this here. Of course, I really liked the solution that Arun provided earlier using area under the curve. That's a brilliant idea. But this is another idea. I wanted to show you the power of randomization. Okay, so if you want to read more, there are many other ways of computing the area of the circle, right? So that's this approximations of pi. There are algorithms from prehistoric, almost like from early history to modern day. There are hundreds of algorithms. One of the simplest algorithms is the Monte Carlo approach. Again, the Monte Carlo approach or the Monte Carlo method is interesting because it tests your understanding of random numbers, right? You're doing a very simple simulation, right? It's a beautiful thing in itself. Again, in an interview, if you cannot come up with this, but if you came up with something completely different solution, that's okay. But I wanted to introduce a new concept, right? In mathematics, because the series here is mathematical programming. Okay, let's go. So I'm just importing random. This function basically says whether my point x comma y, so my circle is fixed, no? My circle is fixed. My circle center, again, this is, okay, so let's go to this diagram. My circle center 1 second. 1 second. I think I did a mistake somewhere. Oh, the circle. I think I did a small mistake somewhere. Okay. So what is the circle center here? The circle center x-axis is 0.5, y-axis is 0.5, right? That's the circle center. And the radius itself is 0.5. Yes, this is 0.5, this is 0.5. I think there is a small bug in my code. Let me fix it as we go. Okay, so whether the point xy is in a circle or not. So that's simple, right? So I think I did a small mistake here, but that's okay. We'll fix it quickly. So if x minus, okay, so if x, so whether the point is within the circle or not is what we are trying to determine, right? So given a point x comma y, I want to determine whether it's in a circle or not. So minus 0.5. So this tells me, so this gives me x minus center square, y minus center square. To this whole thing, I have to compute the square root, right? So to this whole thing, I have to compute the math dot square root. So let me import math also, or I must have already imported it. Okay, import math. So math dot square root. Okay, so what did I do now? I computed the distance of a given point from the center. If the distance is less than equal to, what is my radius? My radius is 0.5. Then return true, else return false. Right? This is my in circle function. Okay, I didn't test it because I ran out of time actually. Okay, so let's see. Okay, so this is cool, right? Math dot square root x minus the center. So this indentation is correct. Oh, sorry, this parentheses are correct. This parenthesis is correct. This parenthesis is math dot square root. Okay, so I don't need this. So I don't need this. Okay, so I don't need this also. Okay, so this parenthesis is matching this. Cool. So square root of x minus center x squared plus y minus center y squared. If this square root of this, basically I'm saying that if the point is less than 0.5 distance away from the circle center, then it is inside the circle or else it's outside. So it's basically determining whether the point xy is within the circle or not. Okay. Then I'm creating this count in circle. Number of points, I'm counting the number of points which are inside the circle as 0. I'm doing these many iterations. Right? Very simple. For I in range n, I'm randomly generating the x-axis, I'm randomly generating the y-axis. Now I'm saying if this is true, if the randomly generated point is in the circle, then I'm counting it, right? So my count in circle is nothing but my m. My count circle is nothing but m. m by n into 4 should give me pi, because m by n equals to pi by 4, right? We discussed this earlier, right? So I'm printing this as my value of pi. Let me see if this code works, or else we'll write some simple test cases. Okay, so there is a problem somewhere. Return false, blah, blah, blah. What is happening here? For I. Okay, okay. So, okay, I'm getting 3.1414. Cool. Let me just do this a little less. What happens now? 3.19. If I'm increasing it, what happens? Again, I'll have to write test cases for this. Okay, as I'm increasing it, takes more time, obviously. As my n increases, it takes more time. Okay, let's just wait for a minute. Okay, 3.1419, blah, blah, blah. Yeah, it makes sense. This is cool, right? Again, the whole Monte Carlo simulation is a beautiful idea. Once you get the idea, the concept is simple. Look at this. What are we doing here? We have this, we have this, we have this. That's it. Now, this whole idea is very powerful in general because, again, you can read, okay, so let me additional, okay. You can read more about Monte Carlo simulation. It's a very big topic. I mean, I can teach, I've learned Monte Carlo simulations during my master's days, and I've spent, this is like a multi-lecture problem, right? It's not, even at a master's, at a graduate level, if you take numerical methods and numerical simulations, there could be 4 or 5 lectures just on Monte Carlo methods, right? So now imagine this method can be extended to finding areas of any random shape. Suppose imagine this black area. I want to find the area of this black region. Area of this black region. Area of this black region. Of course, I can use the integration based method, surely, right? I can say, okay, first I'll compute the area above this, then I'll compute the area below this, I'll add both of them. That's one area, that's one idea. But as long as I have this function which says in black region, as long as somebody can write this function for me, wherein I give the x and y coordinate and it can tell me whether the point is inside the black region or not. As long as somebody can write this function and give me this function. If somebody can do this, I can apply my simple Monte Carlo approach. I can simply apply my Monte Carlo approach. Again, this diagram has been taken from Scratch Pixel. I also have the reference link here. Please go check it out. And okay, so this is one way of computing pi. There are other ways. I just wanted to touch upon one and then we'll close it out. So earlier, before modern computing, all of that, I think the ancient Greeks, and I'll have to look up the Wikipedia links. So people actually tried this. I think, where is the 96-sided? Okay. Again, you can read up all of this. I mean, there is a ton of, there are a lot of mathematicians who have tried this. Ancient times, Middle times, Kerala School of Astronomy and Mathematics, Madhava. I mean, they're phenomenal mathematicians who have tried this across the world, not just in India. Aryabhatta, everybody, right? I mean, people from the Chinese mathematicians, from from Archimedes, from the Greek mathematicians, everybody tried this, right? So one very elegant approach is this. Again, I just wanted to touch upon this because of the beauty of the mathematics in this, or the beauty of the idea. So the ancient mathematician said, okay, circumference by 2r is pi. We don't know what pi is. So they said, let's draw a circle. Let's draw a square inside the circle. Right? Square has 4 sides. So let's say k equals to 4. 4 sides. They said the circumference of this, okay, so let me use a different color. So this color, okay. So they said the circumference, what is the circumference? It is this 4 sides, right? They measured these 4 sides. They summed up the 4 sides and they said the sum of these 4 sides is a good approximation, is a basic approximation to the circumference of the circle. And they knew this circle radius. So initially they took k equals to 4, they got a circle. Sorry, they got a square. So they measured this length plus this length plus this length plus this length. They used this as an approximation to circumference. And they already knew r because they drew this circle, right? So circumference by 2r, they got one value of pi. They said, okay, why should I approximate only with a 4-sided polygon? What if I use a 5-sided polygon? This is a pentagon. This is a pentagon, right? So then they approximated with a pentagon. When you approximate with a pentagon, you know that all of these points, these 5 points, these 5 vertices lie on the circle, right? And you also know that they have to be, if you want a pentagon that is same length sides. What is it called? Uniform pentagon? I forgot some of this terminology from high school, man. Okay, so anyway, that's okay. So if I want this pentagon such that all these sides are same, right? I want these angles. This will be at theta, 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 this will be at theta. And this theta will be 360 by 5. Because I have to find 5 vertices. 1 vertex, 2nd vertex, 3rd vertex, 4th vertex, 5th vertex. So they now embedded a pentagon, right? A pentagon of same sides, same side length into a circle. Now they computed the circumference of the pentagon. This plus this plus this plus this plus this. Now this is a better approximation than the square to the circumference. This 5 sides sum is a better approximation than the 4 side sum. Then they said, why should we stop with pentagons? Let's go to hexagons. So then they drew the 6-sided hexagons, right? Then what is this theta now? First I fix a point here. Then how much should I go before I find the next one? Again, I know that the length of this, 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 all of them I'll try to make them the same so that it becomes easier. Then I just have to measure this length and then multiply it by 6 to get the whole circumference. So they said, if I keep drawing these, first I start with a 4-sided polygon, then a 5-sided polygon, 6-sided polygon, 7-sided polygon. If I go up to 100-sided polygon, I think the Greek mathematicians tried it with some 96 or not, 96 or so. I'll have to look up Wikipedia, I think. So they realized that as k increases, the circumference that again, it's easy to compute circumference because I have to just measure this and multiply it by 6 because all these are at the same angles. Look at this. This triangle and this triangle are equilateral, are exactly the same, right? So this triangle is same as this triangle because this side and this side are the same, this side and this side are the same. If these two angles are the same, this length and this length also will be the same, right? So they just have to measure this length multiplied by 6. They got the circumference. Similarly, they tried with 7, 8, 9, etc. Finally, they came up with an approximation to pi, which is very, very accurate, right? So you can also solve this problem not just using, again, one idea that Arun and others suggested is to use area. The other is to use Monte Carlo approach, right? The other is to use this approximations using polygons, right? So there are many such methods. Again, so some of you have emailed me and asked me about some additional resources. So again, first and foremost, we'll cover more mathematical and numerical algorithms in the future live sessions. We have whole of linear algebra, we have whole of statistics. Again, we'll look at more Monte Carlo approaches also in the future. We have linear algebra, probability statistics, optimization, and every major machine learning algorithm is a form of mathematical programming, right? So one thing that we'll do extensively throughout these live sessions is more and more of mathematical programming. That's why I spent so much time numerical. Okay. Again, there is no type correction. There is no spell check here, so I keep making these mistakes. But if some of you are interested, there is a very nice course at Brown University, I think. BU, I think, is Brown. So just check out a bunch of lecture notes. I also Google searched and I found this book. I have not read this book, but the syllabus or the contents looked good. The best place to learn more about numerical methods is to read SciPy and NumPy reference. Tomorrow's live session, we will spend on strings and regular expressions, right? We have done mathematical programming for a couple of days. Again, tomorrow's live session is also open to everyone. I'll just put out a live session announcement. Again, I'll not make a video. I'll just put out a live session public to everyone. Please attend it. Tomorrow, please refresh strings and regular expressions because this is extremely important. Again, we'll cover some examples. When we cover natural language processing, we'll cover many more string operations and regular expressions and advanced operations later. Tomorrow, we'll just limit ourselves to basic Python programming, strings and regular expressions. The live session is tomorrow, 6 to 8, right? So please, yesterday and today, I wanted to give you a good overview of mathematical programming, assuming that you don't know much of advanced mathematics, or maybe you've forgotten some basic mathematics from your school also. If some of it is complex, please refer the additional material that I give you and try to solve the exercise problems. I just wanted to expose you to or introduce you to a bunch of mathematical tools that are extremely important and extremely useful to understand and to think for a machine learning engineer, right? I'll provide this IPython notebook and a PDF version of it in a few minutes, just under the live session, right? So, thank you, folks. So we'll conduct. So somebody is asking about future live sessions. Again, all the basic Python stuff which do not require. It's called a regular pentagon. Thank you, Bhargav. I was thinking uniform. Regular is the word, right? So the future live sessions that we will conduct. So the future live sessions, anything that does not require you to go through our course, anything that requires only basic Python programming, we'll keep them in the public domain. We'll do public live sessions. Since I expect anybody who knows basic Python programming to know strings and regular expressions, you don't have to know some advanced mathematics or probability or anything. You just need to know basic programming. So we are continuing to keep this open to all. But as we progress through these live sessions, there will be some that we will have to limit only to our students because they'll have to go through course videos. We'll use the same notation, the same code examples. Without that, you will not be able to understand, right? So I'm from pharmacy. Whatever you're giving content, is it enough? Again, the objective of these live sessions, let's make it very clear. I've made it multiple times. It is to introduce you to multiple programming problems, right? Again, I told you, right? A couple of these problems were actually asked in interviews, right? Again, even yesterday's problems and today's problems, some modified versions of them, I have asked in my own interviews. So best book for Python, pick any book, man. Just Google search for Python book for beginners, if you're a beginner, right? So you'll get tons of books. Best Python books, okay, Python for beginners, okay. Why buy a book? There is this nice tutorial by python.org only, no? So very nice tutorial, just get started with this, right? So tons of simple examples, completely, again, if you're completely new to programming, they'll give you learning. So there are a lot of publicly available good material for Python. So please see that, right? Sounds good. Somebody says, shall I join TCS for 1 year until I finish the course? Please don't quit your jobs. If you have a job offer, please don't ignore it. Please join in the job. I've been telling this ever since we started Applied AI course. Please don't quit your job and prepare for AI jobs. Nothing worse than that. If you cannot prepare while working, you're not up to the task. Let's be honest there, right? Somebody says, can we use the same Monte Carlo approach for finding? Yes, you can, Pratik. Good question. Again, the Monte Carlo approach is a non-integration based approach for finding area under some diagram or some shape or some curve. It's a completely different approach. It's a non-integration based approach which uses probability. Yes, you can. No doubts about it. Any math resources to learn? That's what I'm giving. I'll share this document at the end. Again, if you want to learn more advanced mathematical concepts, more advanced numerical methods, again, there is no limit to it. I have taken a numerical methods course in my BTech. I've taken a numerical methods course in my MTech. Right? This is literally like what? 2 semesters worth of course. So again, I don't think I'm that good at numerical methods. My understanding is still basic. I've seen phenomenal guys, right? But here are good resources. It's a good, I just Google searched. I like the contents in this book. There are also a bunch of lecture notes. I mean, if you have followed through these videos, again, these videos will be on YouTube, so you can watch them. I'll provide the IPython notebook. Just like every day, I'll provide it. Just give me a few minutes. After this live session, I'll do it, right? Sounds good, folks. Okay, that's all I had. See you tomorrow. I'm sorry I ate into your dinner time for some of you. It's already 8:30, but see you tomorrow. I'll try to end it at 8 from tomorrow.